Before starting the session, so just want to give the brief introduction about the what is the machine learning and what is the AI. Okay, because you are already familiar with this terminology, what is the AI and the machine learning. So basically, the AI is the like a bigger picture, and machine learning is the subset of machine learning is just subset of AI. Okay, so AI enables the machine to think without any human intervention. Okay, and machine learning is the subset of AI that use the statistical learning algorithms that learn a pattern the data over the time, right? And there is a one terminology that is called deep learning. Okay, so deep learning is another subset of machine learning that filter the data through the multiple layer. Okay, so in this deep learning, we will use the different algorithms like ANN, CNN, RNN. Okay, so in this session, we will work only this machine learning part. Okay, so in this session, we try to understand about what is the machine learning algorithms. Okay, and what are the different what are the different types of machine learning, right? So how can we just implement this machine learning algorithms on a given data set? Okay, so for implementing this algorithm, so we have to use some different softwares. Okay, so I'm just simply okay, just a minute. Okay, yeah. So in the simply you just write here in this Google, you can just write the anaconda. Okay, so everyone please type this anaconda. Okay, so this is the one IDE. Okay, so please open this browser, open this any browser. Okay, and just Google it, the anaconda, right? So because it's a little bit like a very lengthy software. Okay, it's take
Saurabh,
some, yeah. Am I audible?
so yeah, you are audible, but we are only able to see your slides if you are sharing the other window on Google. So I think you have to share the entire
Okay, okay, just a minute,
system
just a
while
minute.
yeah.
Okay.
So you have to click on screen so that we can see
Yes,
all
yes,
the
yes.
screens.
Okay, fine.
Yeah.
Yeah, so please go to the Google. First, you click just write on the Google in your browser. Okay, and after that, you just write this term anaconda. Okay, so anaconda is the one IDE. The full form of IDE is the Integrated Development Environment. Okay, so click on this anaconda. Okay, so I'm right now going to paste this link in the chat box. Okay, so you can also just copy this link from the chat box. Okay, and then you paste this link in your browser. Okay, and then you come to this part. Okay, so here you can see this download button. Okay, so first click on this download part. Okay, so if you just going to click this on the download button, so it will take some few minutes time. Okay, it will take 5 to 6 minute time based on your internet connectivity. Okay, so after that we have to install this part. Okay, so I have already installed this part in my computer system. So I will only tell you like what are the different steps to install these things. Okay, so first you click this software. Okay, then I will explain this all the things. Okay, so it will take some time. Okay, so I will try to explain the another things. So another there is
Saurabh,
one. Yes,
so sorry.
yes.
So are you guys able to follow up till this point, guys? And started downloading? If yes, type in the chat box yes.
Okay,
Yes, yes, yes. Okay. Yes, okay. Yes, all right. Awesome. So majority of the people has followed up, but I think one or two people are is still saying no. Saurabh, can you just repeat the steps of going to Google and
yes,
then
yes.
yeah.
Yeah, sure, sure. Yeah. So just click on the Google. Okay, and after that you just after that you just search this terminology anaconda. So just this is the this is the software. Okay, that is the IDE kind of software. So IDE is basically integrated development environment. Okay, so in this IDE in this particular software we can just open our Jupyter, Spider, Python, and there are different platform are available in the software. So when you just download this software, after that you have to click on the installation part. Okay, so when you just finish this all the installation part, so after that you are able to see this kind of screen. Okay, so just a minute again. Just want to share my screen. Okay, yeah. So when you just finish this downloading part, after that you can see this kind of screen. Okay, so that is called Anaconda Navigator. Okay, so in this Anaconda Navigator, you can see here, this is the Jupyter notebook. Okay, this is the Jupyter lab, and inside this Anaconda Navigator there is a spider. Okay, so in this today's workshop we will use this spider. Okay, for creating the creating the one web app. Okay, because we have to in this complete workshop we will learn how can we just build the machine learning model, and how can we also make a web app for the particular machine learning algorithm, and how can we just deploy that particular web app on the cloud. Okay, so this is the main agenda of this workshop, right? So can anyone write in the chat box what is the status of your and what is the status of your downloading? Have you finished your download? Okay. So after that, you can just write in the Google, just write the Google Colab. In the Google, you just go to you just write here Google Colab. Okay. You simply write Google Colab. Okay. So when you just run this Google Colab in this Google, after that you will get this kind of link. Okay, so just you click on this first link. Okay, so this is your Google Colab. Okay, so basically Google Colab is this is a one online Jupyter notebook. Okay, so it's provide the cloud based interpreter where we can just write the Python code. Okay, and we can also compile our all the Python code on this Google Colab. Okay, so you can see here, this is the notebook. Okay, so when you just click on this particular notebook, then you can see this kind of notebook. Okay, so I have already opened this Google Colab, and just I click these things. Okay, so I got this kind of notebook. Okay, so please all of you just open this and Google Colab also. Okay, through and yeah, please log in this Google Colab with help of your email ID. Okay, so first you have to make sign in this Google Colab. After that you can only use this Google Colab. Okay, so please register through your email ID and try to log in with your registered email ID. Then only you can able to log in this Google Colab. Okay, so first you open this Google Colab. Okay, I just want to repeat this whole thing again. So first you open this Google Colab. Okay, and after that you just sign in through your registered mail ID. Okay, and then you just click on the new notebook. Okay, and then you just open this new notebook. Okay, here we will write all the code related to Python programming, right? So this is the online interpreter. So we will build the machine learning model in this Google Colab. After that, we will use this Anaconda. Inside the Anaconda, there is like a spider. Okay, so we will use a spider software to create the web applications, right? Yes. Okay. So please wait 2 to 3 minutes for the downloading of Anaconda. Okay. So in this meantime, we will start the theory of machine learning, right? Mehul, am I audible? Mehul, am I audible? Okay, fine. Yes. Okay, fine. So first we are going to start the theory of the machine learning. Okay. So as we discussed, right, like what is the AI and what is the machine learning and what is the deep learning, right? Now we are going to understand about what is the what is the type of machine learning. Okay. So let me share the full screen. Okay. Let me share this complete PPT. Okay. So machine learning is a subset of artificial intelligence. Okay. And ML is the study of computer algorithms that improve automatically through the experience, right? So ML explores the study and construction of algorithms that can learn from the data and make the prediction on data, right? So based on the more data, machine learning can change the actions and response, which will make it more efficient and adaptable and scalable. Okay, so this is the machine learning. And what is the deep learning? So deep learning is a technique for implementing the machine learning algorithm, and it is used the artificial neural network, okay, for the training the data to achieve the highly decision making. Okay, So the neural network, perform the micro calculation with the computational on many layer that can handle by the that can be handled like human, right? Now I'm coming to the this different types of machine learning. So basically there are three types of machine learning. One is called supervised machine learning, another one is called unsupervised machine learning, and the last one is the reinforcement learning. Okay. So what is the supervised machine learning? So in a supervised machine learning model, the algorithms learn on a labeled data set. Okay. So what is the labeled data set? So labeled data set means there will be several features, okay, and there will be one target, okay. So like the equation y is equal to x, okay. So here, y is your dependent variable and x is the independent variable, okay. So based on the different value of x, okay, different value of x, all the value of y will be depend, okay. So in the complete supervised machine learning, we will use the label data. Okay, there will be one features. Okay, and there will be one target. Okay, so that is called the predefined tag. So all the features are associated with the predefined tag, right? So for just I'm taking the one example, like suppose we are taking the one diabetic data. Okay, so what will be the feature in this diabetic data? So there will be like what is the body mass index, what is the insulin level, what is the sugar level. Based on that, we will just predict that this particular person suffering from the diabetic, or this particular person is not diabetic. Okay, based on that feature we can decide that. Okay, so this is called the data. Okay, so in this label data, there are two things. Okay, one is called categorical label data, and another one is called continuous, right? So, based on these two things, we are going to classify the supervised machine learning into into two parts. Okay, one is called classification, another one is called regression. Okay, so in this classification, we will deal with the categorical data. So what is the meaning of that categorical data? Like I'm taking the one example of diabetic. Okay. So if any person is suffering from diabetic, okay. So so that will be, suppose we are that particular person as I'm considering as a one, and if any person is suffering from non-diabetic, so that particular person we are going to consider as a zero. Okay. So here we can divide diabetic and non-diabetic into 1 and 0. So we can just classify these things in the form of binary. Okay. So that is called classification. Okay. So, and suppose I am taking the one example of house price. Okay. So, house price is like a range. Okay. So based on the features, like what will be the features? Feature would be like your number of bedrooms, your number of floors, your number of, BHK. So based on this type of requirement, based on this kind of feature, you target. So target is here price. So based on that, based on that features, your target will be continuous. Okay, so the price of flat will be in the range, like I suppose 55 lakhs to 1 crore. So this is the range. We cannot classify into the binary form. We cannot be classifying into the 0 and 1. Okay, so that is called the regressions thing. Okay, so I'm just so diabetic of patient, I'm taking one example. So diabetic of patient, that is you can remember as a this is a classification thing, and the price. Okay, like flat price predictions. So that will be the regression. Okay, so that is the real life example of classification, and that are the real life example of classification and regression. So in this classifications algorithms, okay, in this classification problem, so there are several machine learning algorithms like naive-bayes, classifier, decision tree, support vector machine, random forest, and k nearest neighbor. Okay, so basically these are the classification algorithm. Okay, so similarly, these all are the regression algorithm like linear regression, support vector regression, decision tree regression, lasso regression, rigid regression, right? So these are the all regression problem. Okay, and all these are all the classification problem, naive-bayes, classifier, and decision tree. Okay, so so we will take one example of the classification problem. Okay, and then we try to build the machine learning model. Okay, different classifier machine learning model. Okay, so So I'm just trying to explain the another part of machine learning that is called the unsupervised machine learning. So if there is no any target column, if there is no any predefined tag, so that is called the labeled data. That is called the unlabeled data. Okay. If there is a tag, so that is called the labeled data. So labeled data we have already discussed for the supervised machine learning. If there is no if there is like unlabeled data, if there is no labeled data, so that time we go for the unsupervised machine learning. So how can we deal with the unlabeled data? So for this kind of data, we will make the cluster. Okay, like I'm taking the one example, like Indian population. Okay, so suppose I just want to divide the whole Indian population based on the income. Okay, like yeah, if the income is more than 10 lakhs, so I will consider as a one kind of group, like that is a lower income group. And if the income is uh, from 10 lakhs to 25 lakhs, so that time we called as a middle income group. Okay, and if income is higher than 25 lakhs, so that will call that time we can call it as the higher income group. Okay, so here based on the income we are trying to make the cluster. Okay, so we are that is try to make the cluster. Cluster, it means try to make the try to create a groups. Okay, so that is called the unlabeled data. Okay, that is called the unlabeled data. So in this kind of data, we will use the different kinds of machine learning to generate the cluster. Okay, so there is k-mean clustering, like hierarchical clustering, agglomeratic clustering, Gaussian mixes. So these are the different clustering. With help of this type of clustering, we can just create the cluster. Okay, so so these are the, again I'm trying to repeat this all the things. So there are three types of machine learning. One is called supervised machine learning, another one is called unsupervised machine learning, and the last one is the reinforcement learning. So there are two types of supervised machine learning. One is called classifications, another one is called regression. And unsupervised learning is the only part in the unsupervised machine learning. There is only one thing, one that is a cluster. Okay, so in this cluster, there are several algorithms like k-mean clustering, hierarchical clustering. In this classification problem, your target column will be categorical. Okay, and we will apply this decision tree support vector machine random forest and the k nearest neighbor. Okay, and your regression problem, your target column will be continuous. Okay, so like price flat price predictions. Okay, so that would be considered as a regression problem. So regression problem are linear regression, neural network, support vector regression, decision tree. Okay, so these are all the regression problem. Okay, so another and the last one type is called reinforcement learning. Right? So what is the example of reinforcement learning? Like there will be like one agent. Okay, and agent will be learned from the environment. Okay, suppose I'm taking one example of like baby child. Okay, so baby child, how to like baby child want to learn how can we just walk on his feet. Okay, walk on his and her feet. Okay, so they first try to try to take some baby step, and then he fall down. After that, again try to learn from the environment, and finally doing the lots of practice, they are able to work on his and her feet. Okay, so that is called the reinforcement learning. Okay, like if you want to learn if you want to learn like how can we ride a bike. Okay, and how can we just drive a car. So that time we have to follow this reinforcement learning. Okay, then that time any driver will be like driver will be just act like agent. Okay, and the rest of the thing will be like environment. Okay, they will try to see the left and right, and based on that they try to use the different clutch, brake, and the accelerator. Okay, so based on the environment, they try to learn how can we just drive a car, or how can we just ride a bike. Okay, so that is called the reinforcement learning. Okay, so we in this reinforcement learning, there is we try to also try to do the some supervised machine learning, and after that we just deploy one agent. Okay, and agent will try to learn from the environment. So that is the example of reinforcement learning. Okay, so in this session we are going to learn about the supervised machine learning. Okay, and we will take one data from we will take one label data, and based on that label data we try to build the machine learning model, right? So so this is the this is the classification problem. Okay, So if you just take the what is the difference between the supervised machine learning and unsupervised machine learning. So that is, in the supervised learning, there is two things. One is classification and regression. So we will put the label data in the two supervised machine learning algorithm, and that particular machine learning algorithm, they classify the data into the two things. Okay, one they can just try to classify the data into the also they try to predict the data, right? So this is called the classification part, and this is called the regression part, right? If there is a continuous data, so that time you go for that time you try to draw a line. So that will be considered in the regression problem, right? So this machine learning life cycle is very important. So you can just you can take this snapshot of this PPT, okay, or you can just write the notes on this just write down this all the 5 and 6 steps, okay, because we are going to just follow this step only, okay. So in this throughout the session, okay, in this complete 3-hour session, we will follow only this step, okay. So first we will gather the data, okay. First we will gather the unlabeled data, okay, label or unlabeled. So this time we are going to gather the label data. So label data, it means there will be like feature and there will be like predefined target, okay. So in this session we try to gather the one label data, okay. Then we do the data pre-processing, or we call it as the EDA, okay, that is exploratory data analysis, okay. After that we will just train our model, okay. So first, we divide the data into the two parts. One is the training data and test data. Okay, so we will build our machine learning model on the trained model. Okay, then we test our model with help of this test data, right? And then we finally think, how can we just deploy a model? How can we just make a model, and how can we just deploy the model? Okay, so for the deployment of any model, we have to create one web app like application. Okay, because web like application gives the graphical user interface. Okay, where the user can directly put the input value, okay, and based on that input value, the model will predict something. Model will predict like the particular person is diabetic or not, and what will the range of the particular price, okay, flat, okay. So these are the very important steps, okay. So we are going to just create one project, okay. So if we are going to if you're going to just to make any project, so that time we have to first create the what is the flow chart, okay. What will be the work of flow, okay. So that this is the flow, okay. So this is the life cycle from starting to end, okay. So that in the every machine learning project, we will try to first create this life cycle, okay. So how can we do each and every step in the to the completion of any machine learning project, okay. So first we gather the data, we do the data pre-processing, then we train our model, then we test our model, and then we deploy our model. And after that, just we will uh, we will just monitor our model, okay. So it's a different thing, okay. If you have a very large number of users, so that time sometimes the model becomes so underfitted or overfitted, okay, because we have not trained our model properly. So that is a different thing, okay. Like if the Netflix or YouTube like if the Netflix and any YouTube particularly deploy any machine learning algorithm, okay, for the very large number of users, so that time there is a chances the model will be like underfitted, overfitting, model overfitted or underfitted, okay. But in our case, we have a very less data. Like if the data is the number of like 10,000 rows, and like suppose like 700 or like this kind of rows, okay, on this kind of columns, okay. So this is a very small data, okay. So there is a very less chance to for the model overfitting, okay. So because we will just divide the model into the 80% as a training data and 20% as test data, and then we try to just make this model, okay, fine. So this is a very important this machine learning lifecycle model. So you can just write down just write now this step, okay. Now we are coming to the this part, like what are the different libraries, so we will use the different library and functions for creating the any machine learning model, okay. So for creating the any machine learning model, now we will use the sklearn library. That is what is the full form of sklearn, that is called the scikit library, okay. So we will use the sklearn library. Okay, and then we just we apply this. Uh, we will just apply this support vector machine. Okay, so first we try to we are going to try to build a machine learning model with help of support vector machine. So we will follow these steps. Okay, so this is the steps of any machine learning model. Okay, suppose you are going to build any logistic regression or linear regression, okay, or random forest or support vector machine. So we have to follow this step. So first we import the library, then we just import the Skill-Learn, import SVM. Okay, so basically this Skill-Learn is like the machine learning library. Okay, so we will follow each and every step line by line, right? So now we are coming to the Google Colab and try and just you can please open your Google Colab and just try to start the coding part. Okay, how can we just create a machine learning model, right? So please open your Google Colab. Okay, right now I'm just so trying to stop this PPT. Okay, and come to the Google Colab part. Okay, okay. Are you able to see my screen? This Google Colab. Please write yes or no in chat box. Yes, Manishi, you can also use the VS Code. Okay. Yes, you can also use the VS Code. Okay, VS Code is also fine. Okay, but this time you can just you try to explore this Google Colab. Okay, that will be the fine. Okay. VS Code, so basically these all are the interpreter. Okay, VS Code is also interpreter, that is called Visual Studio. Okay, but we because we are going to deploy these things, so that time we are going we are definitely use a different library like Pickles in Streamlit. Okay, so with help of this Streamlit, we create the web applications. Okay, so please just use this Google Colab and also try to install this Anaconda. Okay, so anyone tell me what is the progress of your Anaconda? Have you just downloaded your Anaconda from the Google? Can you write in the chat box? What is the status of your Anaconda downloading? Have you finished your download? Anyone can type in the chat box. Okay, fine. Okay, so download, yes. So Manishi, you have downloaded successfully. Fine. Okay. Uh, and Avni also downloaded. Fine. Okay, so please click on the please go to the download section and try to install the Anaconda. Okay. Please go to the download section and try to install the Anaconda. Okay, so you just click on the next button. Okay, so you simply you try to install the Anaconda through the you just run as administrator. Okay, and then click the next. Okay, and install for the just for me. Okay, not for the all user, you just click on the just for me. Okay, and then you wait, it will take some 15 to 20 it will take 10 to 15 minutes time. Okay, so please wait. Okay, still you can wait for the 10 to 15 minutes, right? It will take some time. Sir, how to load the data in Google Colab? Yeah, sure, I will tell you. Okay, yes, I can tell you how can we just load the data in Google Colab.
Hey Saurabh, so we can share the Google Sheet link in the chat.
Yes, yes. So can you share the data sheet on your mail ID?
No, you can upload the Google that Excel sheet into Google Drive and you can share the link.
Okay, fine. Yeah, just a minute. Yeah.
Yeah,
Okay.
yeah. And so that people can take it from there.
Yes. So please check the link of Google Drive in chat box. Okay. So just click on this Google Drive. Okay, and please download the diabetic data. Okay. So this is the label data. Okay, and this is the diabetic patient data. And based on this particular data, we will build the machine learning model. And please confirm in chat box, are you able to download this file? Okay, fine. Okay, yeah, everyone please download this file. Okay, and we will start the coding on Google Colab. And please everyone try to install the Anaconda. Okay, So if you have already downloaded Anaconda, so please go to the download section and just try to install it by using the click on the next, okay, and just select the in the installation path, just you select as install as a just me, okay, not for the all user, you just install it as just me, okay. If you face any difficulty during the installation, so please write in the chat box, okay, because Anaconda installation is very important, okay, because we have to make a one web application with help of a spider, okay. So it's only possible if you downloaded the Anaconda, then we can only use the spider. Okay. So everyone, please open the Google Colab. Okay. And please follow the each and every step line by line. Okay. And anyone if face any error, so please write in the chat box, or you can just copy your error and paste in the chat box so that I can just check your what is the error, and accordingly we can rectify the all the error. Okay. So please everyone just follow the each and every step, and you can if you have any doubts, so you can also ask these questions in chat box. Okay, why you are going to use this library and what is the need of this library. Okay. So I will try to explain each and everything, okay, line by line. Okay. And if you miss any things, so you can also ask in the chat box. Okay. Yeah, please. Okay. So for building, yeah, Google Sheet. Sorry. Okay, fine. So, yeah, Isaac, you can download the data sheet from the drive. Okay. So we have shared the one drive. Okay. This is Google Drive. Okay. So I'm just again, I'm trying to send this link of the drive. Okay. So you can just click on this particular drive and please download the data. Aman, you are not able to copy this. So please, Aman, don't do the copy. Okay, you uh, simply see on the top of the. You can simply see on top. Okay, top of the your browser. So there is a like download option. So you can just click on the download part. Okay, if you are not able to download this file, so you just see there will be one download options in the top side, okay, top right side. Okay, so you can see there and just you click on that. No, it's not a part of MS Word. Okay, that will be downloaded in the form of Excel. Okay, this file is the file extension is this .csv. Okay, so please everyone confirm this. Have you downloaded this file, and what is the file extension? Is it the extension of file is .csv, or you are getting some other file extension? Yes. So Shivani Vijay, yeah. So this is the CSV. Fine, yeah. This is the CSV file because we can only right now we are going to use the CSV file. We can also use the Excel or any TXT file. But this time we are going to use the CSV file. The full form of the CSV that is called comma separated value. Okay. So we are in this particular uh, data, we are going to use the CSV file, right? Okay. Okay, fine. So yeah, for the building the any machine learning, there are few requirement of essential Python library. Okay. So we have to just write the, or we can say as the, we have to just import the essential Python library. Okay. So there are few libraries, essential Python library that NumPy, Pandas. Okay, so NumPy used for the numeric and numeric and scientific computing. That is called the numerical Python. And Panda is a very important Python library. Okay, this Panda library used for the creating the data frame. Okay, so this NumPy and Panda is very important and very essential Python library. And so first we will write here. Okay, so and simply you just write in this Google Colab like import, okay, NumPy as NP, okay. So I'm importing the NumPy here, NumPy library, and we are going to define NumPy as NP. So next time if I'm going to call this NumPy array, so that time we will not write NumPy, we will simply write NP, okay, because we are defined here NumPy as NP, right? And simply I'm writing here this Panda. So NumPy is used for the numeric and scientific computing. Okay, for the creating the any array. Okay, so that time we go for the this NumPy. Okay, right. So if you have any questions related to this particular library, Aman, please send me your mail ID. This thing is not supported. Sorry, Aman, you cannot do that on your smartphone. So please join with your laptop. Okay. You cannot perform this task on mobile phone. Okay. So please join with the laptop, or you can just open the Google Colab on your browser. Okay. And you can try to perform this. Okay. But it will be better if you join through your laptop. Okay, fine. Yes. After that, you just import this Panda. Okay. So you simply write import pandas as a PD. So next time we will use the panda. In place of panda, we will write the PD. Okay. Now after that we have to use the standard scalar. Okay. So because we are going to, if you're going to use the this .csv file, this kind of data, so you have to also we have to also standardize the data. Okay. We have to, it means what is the standardization of data? We have to, we have to convert all the data as a unit variance and the zero mean. Okay. So for that, we have to just import these things from Skill-Lync. So basically, Skill-Lync is a it's a Python library that is used for the machine learning and the pre-processing thing. Okay. So simply you write here from Skill-Lync dot pre-processing. Okay. Import standard scalar. Okay. So in the standard scalar, S should be capital. Okay. Because this is a predefined things. Okay. We cannot change that. So that is a standard scalar. In the S will be also capital. Okay. If you are writing a small thing, so that time you will get the that time the interpreter will throw error. Okay. The error will be like this particular term will be not defined by the Python. Okay. So this kind of error we will this kind of error will be thrown by the interpreter. Okay. Yes, Realme, you can use the Jupyter notebook. Yeah, definitely you can use the Jupyter note, but please use this Google Colab. Okay. You can also use the Google Jupyter notebook, but because we are going to deploy these things on the we are going to make a web application. So for that we have to save the model. Okay. So for saving the model, we have to install the pickles library. Okay. So you can also do this on the on Jupyter notebook. That will be fine. But you check, we have to install the pickles. Okay. And you have to also check you have to install the different library. Okay. But in the Google Colab, that we have get this kind of all we will this kind of libraries already installed in the Google Colab. So no need to install any library here. So that's why I'm suggesting here. You can for this session you can use the Google Colab, and after that you can also use the Jupyter notebook. Right. Okay. If you've already installed the essential Python library with help of pip install, if you are if you're writing in the Google Jupyter notebook, and if you're getting this kind of error, this particular module is not found, so that time you simply write pip install. Suppose you are getting this this panda module is not found. Okay. Or any module is not found, so that time I'm writing in chat box, you simply write pip install and that particular module name. Okay. So with help of this pip, we can install that particular module. Okay. So you can use the Jupyter notebook. That is not an issue. Okay. But if anyone going to use this machine learning model first time, if anyone going to just build the machine learning first time, so please follow my each and every step. Okay. That will be easy for understanding this kind of model creation. Okay. Yes. Okay. So yeah, you are getting the what is the error you are getting? Like Devan Preeta Chakravarti. It's a standard scalar. Yeah. Okay. Fine. Yes. Yes. It is a standard scalar, right? Okay. After that, after that we have to write here. Because we are going to build the machine learning model, so that time we have to also divide the data into the training data and test data. So what is the meaning of training data and test data? Suppose I am just we are going to learn the complete machine learning 3 hours. Okay, I'm going to teach you machine learning 3 hours. Okay, and after that, after this 3 hour, I will take one exam. Okay, suppose there will be no exam, but I'm saying that I will take one exam. Okay, so suppose in the exam, in this examination, I am asking 5 questions, only 5 questions. Okay, but you are not able to answer all the 5 questions. So what is the meaning of that? It means you have not learned anything. So that is called testing thing, because I have already taught you 3 hours in this complete complete machine learning, and I just want to test you with help of these 5 questions. Okay. So similarly, if you are going to build any machine learning model, so we have to just take our model. So for this testing of model, we simply divide the data into the training data and test data. Okay. So in everywhere we also do that, like the training data will be large, okay, because suppose the 3 hour syllabus is very large, okay, but in the suppose the test duration is 10 minutes, okay. So in this 10 minutes, I will ask for 5 questions. So simply the test data is very small, okay. So similarly, we will divide the data into 80% data as a test data and 20% data as a 80% data is a training data and 20% data is a test data, okay, right? So we have to simply write this library, like that is called model selection. Okay, so you have to write like from sklearn. This we will write like this sklearn dot model selection, model and underscore selection, right? Okay, and we will here import the train and train underscore test underscore split. Okay, so we are splitting the training and test data. So simply we write import train underscore test underscore split. Okay, right? And first we will build the machine learning model with help of support vector machine algorithm. Okay, so first we will try to build the machine learning model with support vector machine algorithm. Okay, then we will discuss all the kind of classification. But first we try to build the we are trying to build the machine support vector machine. Okay, model. Okay, so simply for the importing the support vector machine, you just write from sklearn, right? And this you write just write the import svc svm. Okay, that is a support vector machine. So this is the one kind of machine one kind of classification algorithm. Okay, we will discuss later what is the mathematical integration behind the same, and how can we just build the machine learning model with help of support vector machine, right? Okay, then after that we are going to just import another library that is called sklearn dot matrix. Okay, and we are writing here import accuracy score. Okay, accuracy underscore. Okay, so basically as accuracy score is basically test marks. Simply I'm asking the 5 question and then you are getting 20 out of 20. So that is called as accuracy score. So we will build the machine learning model under training data. Okay, so training data is 80%. We build the machine learning model as be a machine learning model. And when you are going to test our model with help of test data, so if at that time you are getting those 70% marks, so that 70% mark will be considered as a accuracy score. Okay, so accuracy score is nothing but this is the test score of your machine learning model. Okay, so we are simply defining one function here in this particular sklearn matrix library. Okay, accuracy score, right? And this is also function train and test train underscore test underscore split, right? Okay, so now after that, now we are trying to running this code, and let's say if there will be error, so we will rectify the error. Okay, so it will take some time. Okay, yes. Okay, so now you can see this. Okay, so it's throwing some error. Okay, so let's see what is the error. Okay, So it's showing here that is the showing Skill-Learn, and that is the pre-processing. Okay, so you check this. I think let me check the spelling. Okay, so everything is uh, yes. So that is the standard scalar, right? So we have to write here standard scalar. Okay, so we have missed the D things. Okay, so now it's fine. Okay, so now there is no error. Okay, so this is the interpreter. Okay, if you just miss the any spelling, okay, so that is a typological error. Okay, so if you miss the any type, if you do the any typing error, so that time it throws an error. Okay, so we have to check like what is the spelling. Okay, and if you're based on that particular error, we have to rectify that particular error, right? Now we are going to upload the data. Okay, so how can we upload the data in the Google Colab? Okay, so simply we will write from, okay, Google Colab. Simply we write google.colab, okay, right? And you write import file, okay. And after that, no, we will write uploaded, okay. And then we just write file files dot upload, okay, right, okay. So now we are going to run this code, okay. Yes, so we are getting error this time also. So I think again we missed any typological error. That is the Google sorry, Colab imports. Sorry, this is the files, okay, because we have defined here files and writing here file. So the both should be same. Okay, so this time I just, if you're writing, if you are declaring something here as a file, if you are just calling this is upload is basically a function. Okay, so if you're getting, if you see any kind of parenthesis, okay, any kind of a small bracket, okay, so that time it's only reflect the this is a function. Okay, this is the method. Okay, so in this here we have defined as a function here the files. Okay, if you're and then we are going to write as a file, so that time is definitely throw error. Okay, so you can check the error here. They are showing the error cannot import the new files from the Google Colab because we have defined here files, right? So now you run these things. Okay, so this time there is no error, right? So simply we have to know, if you're going to write the Python program first time, so don't worry if you're getting the so much error. Okay, you don't worry if you're getting so much of so much of unwanted error. Okay, you simply read the error. Okay, because this is the interpreter and each and every error indicates the some hints. Okay, and based on that particular hints we will rectify our error. We will try to just correct our error. Okay, so don't worry. Okay, so simply we have to just upload the data. So everyone please click on the choose file. Okay, so simply you click here. Okay, and select the file name. Okay, so everyone please download the file from the Google Drive. Okay, if you've already downloaded the file, so please just browse your file. Okay, and then you just select your file here. Okay, so simply you can see here it's 100% done. Okay, so we successfully uploaded the file here, right? So we have successfully uploaded the file. Fine. Okay, so now we are going to create the data frame. Okay, so please everyone confirm, is there any problem? Yes, Praveen, what is the target variable? We will know as okay, fine. Thank you, Sivan Vijay and Deepa Pritam Chakravarti. Okay. Yes, Praveen, your question is right. What is the target variable? So we will discuss later what is the target variable. But if you're asking the questions right now, so I will just give you the hints. Your target variable will be your outcome. Okay. So see, you can see your data set in the outcome. There is 1 and 0. Okay, right? So that is the target column. If there is if particular person is a diabetic, so that time is represent 1. If there is no diabetic, so that time you represent the 0. So your outcome is the your target, right? Okay, fine. So now we are going to create the data. So resend the drive link. Okay, yeah, just a minute. Okay, just a minute. Yes. Yes. Okay.
Saurabh,
So
I
sorry.
think you are sending the file to me in person.
Okay, sorry.
So yeah,
Okay, sorry. Yeah.
okay, no
Okay,
worries.
fine. Yeah. So yeah, please. Yeah. Assis, you can just download this file from this link. Okay. So please click on this link. Okay, and download the file. Okay, and please follow this each and every step. Okay. Yes. So now we are going to create. Now we are going to create the data frame. Okay, so how can we create the data frame? So with help of PD. What is a PD here? PD is basically pandas. Okay, so with help of this library, we will create the data frame, right? Okay, so you simply write here. We are creating the data frame name. So simply I'm just declaring the data frame name as a diabetic underscore data set. So simply I'm writing here diabetic. Okay, diabetic underscore data set. Okay, I'm writing here PD. PD is basically panda. Okay. So because we have already defined as a panda as a PD, so we will definitely use the PD. We cannot use the panda. Okay. So writing here. Uh, See, these are the suggestions. Okay. That's why I'm suggesting you why to use the Google Colab. If you're writing here the PD underscore read, if you're going to just give the underscore, so that time you are able to see this kind of things. Okay. You can also import the HTML file. You can also import the Excel file. So this kind of file you can upload here, HTML, STF. Okay. So these are the files. Okay. You can also explore these things. Okay. So you can also upload the SQL table, also table, XML. So these are the different types of file we can use here, right? Okay. So you can select here PDF underscore as a CSV because what is our file extension? Our file extension is the CSV. Okay. So you can we have to use the CSV file. Okay. So you just copy this file, because we have uploaded the data here. So you can sorry, I'm unable to just copy it here from. Okay. So simply you write here. Okay. So you can just copy if you are able to copy this thing. So you can just copy the file name and simply write in the single quotes. Okay, so you just write diabetic dot csv. CSV is your file extension name and put in the single quotes. Okay, and now you just run this code. Okay, if you're getting error, so okay, so this time there is no error. Okay, so we are able to just create a data frame. Okay, so now we are going to print the first row of data set. Okay, so just a minute. Yeah. So now we are going to create the first 5 row of data set. So how can we just find out the first 5 row of data set? So you simply write, I'm just trying to copy these things. Okay. So you just copy this thing and paste here. Okay. And then after that, you give the dot and use the function as head. Okay. Simply write head. Okay. So basically head is the one function. Okay. So if simply you write the that is the that is the your data set name or that is data frame name. Okay, so this is your data frame. We have declared the data frame name as a diabetic underscore data set. Okay, and simply use the this head function. Okay, now you run this code. Okay, so now this time you are able to you can also open your Excel file and check. So if you can see this Excel file and you can just compare the result. Okay, so with help of this head function, we can see the top 5 entries. Okay, in this data set. Like okay, so the columns name one is pregnancy, glucose, blood pressure, skin thickness, insulin, BMI. Okay, so what is the BMI? That is the body mass index. Okay, so you already know how can we calculate the body mass index. Okay, so and this is the diabetic. Okay, and this is the age and this outcome. Okay, so outcome is here in this data set. The outcome will be your target column. Okay, because with help of this all features, with help of this all parameter, we can predict that the particular person is diabetic or not. So this is already predicted by someone, okay, because we are going to learn the supervised machine learning. So suppose who is the supervisor in this case? So doctor will be the supervisor, because doctor has and already analyzed all the data, and after that they have after that they have decided with help of this data this particular person is diabetic or this particular person is not diabetic, okay. So that's why we are called as supervised machine learning, because that is the already this data is already created by with created with help of any supervisor, okay. So doctor, teacher, that are the basically supervisor, because they are going to examine the things, they are going to just making the prediction of things, okay, based on the past history, okay. So that's why I call the supervised machine learning, because we are trying to learn with help of any supervisor, okay. So all the columns will be the feature column, and this outcome column will be your target column, right? Okay. So this is fine. Okay. So now we how can we just you can also you can also check your with help of tail columns. You can also, if you are going to write that in place of head, if you are going to write the tail, so that time you will get the top bottom 5 entries, okay. So you can try, okay, you can also try in place of head, you can simply write the tail, okay. Now if you are interested to check what is the number of row and column in a data set, okay. So what is the structure of data set? What is the number of row and columns? Okay. So you can simply just copy these things. Okay. This is your data frame name. So we will use this. We will use this data frame name throughout the session. Okay. So simply you just write here shape. So basically that is the function. So simply just write the shape. Okay. Now you can just run this. Okay. Now you just run these things. Okay. Yes. So you can see here, this is the number of row and column. Okay. So 9 is a basically column. You can just also count the columns name, like pregnancy is one column, glucose, blood pressure, skin thickness, insulin, BMI, okay, diabetic, age and outcome. So these are the 9 columns, and the total number of entries are the 768. Okay. So this is the shape of our data. So in our data set, we have 768 rows and 9 columns, right? Okay, fine. Okay. So how can we check the what is the mean, what is the standard deviation in data set? Okay. So we with help of this, describe functions. Okay. With help of this describe function, we can get the all the details about this particular data set. So simply you just write here, okay, data set, and simply you just write the describe functions. Okay. So these are the basically functions, okay, inbuilt in pythons, inbuilt in the different library of Skill-Lync. Okay. So simply you just write the describe function, okay, describ, describe function, right? And now you just run this. Okay. Okay, so this time you can see this is the count, this is the mean, this is the standard deviation, this is 25 quantile, this is a 50 and 75 max. Okay, so these are the all the details about the data, right? Okay, so if if you are going to check, what is what is the count of your 0 and 1. Okay, so you can see here in this data set, okay, that is a target column. Okay, so I'm just simply just want to count what is the total number of 0 and 1 inside the outcome columns. Okay, so how can we just do that? So we can simply write here. Okay, first you write the data frame name. Okay, and simply you just write inside this list, okay, and put the single quotes. Okay, so if you're going to put the single quotes, so that time you can see, that time you are able to get the all the kinds of all these 9 columns. Okay, so we have to count the 9th column, we have to count the only outcomes columns. Okay, so simply click the outcome. Okay, no need to write so much code. You can just put the simply put this single quotes. You are able to, that time you are able to get all the kinds of columns. Okay, and simply just put the dot value, okay, and count function. Okay, so this is the function name is the counts. Okay, so if you're going to use the function, so simply give the parentheses. Okay, now you just run this. Okay, so you can also check, so in this particular data set we have total 500 patients are diabetic. Okay, No, sorry, 526 is non-diabetic, okay, and 268 pattern is diabetic, okay. That is a 0 and 1. So in this database, we have a zero. Total number of 0 is 5,000, and the number of 1 is 268, okay. Right. Any other question till now? Any you have any question? Yes, sir. You can you do first program because I have error, okay. Yes. What kind of error you are getting? Please paste in the chat box. Okay, so please see this error. Okay. Yes, the file name is not found. Okay, if you're getting this kind of error, no, so you check the spelling of, suppose you have downloaded the file twice. Okay, so if you're going to download the files twice, so that time, they write the file name in the bracket, they write the 1, 2, 3. So it's represent the number you have downloaded it twice and thrice. So you check your file name properly and put the same file name. Okay, you put the same file name, that time only you can get your proper file in your data frame. Okay, anyone, if you're getting any this kind of error, file is not found, so simply you check the file name. Okay, I think there is some spelling mistake, or you are going to use the capital or small letter, so you can just correct your file name. Okay, right. And you are getting the error like pd dot read underscore diabetic. Okay, so 21. So sorry, I'm unable to I'm not getting your what is kind of error you are facing here. Okay, yes. So the file showing not found. Okay, so please check your file name. Okay. So if you're getting this kind of error, so please check your file name and please explain me the last two comments. My connection was lost. Okay, fine. So Divya, which last two comments? Okay, so in the last two, rectified. Okay. Yes, Sivani, are you getting the output? Okay, fine. Yes, yes. Okay, thank you. Yeah. Yeah, in the please show me the first program. Show me the first program, sir, please. Okay, yeah. So this, yeah, you can check here. This is the first program. Okay, you can also, if you are, you can also take the snapshot here. Okay. So this is the first program here. Okay. So first, you just import this essential Python library. For the uploading the any files, you can select here. Okay. Then you just create the data frame name, right? Okay. So you can create the data frame name with any variable. So it's not mandatory to write the diabetic name. You can write X, Y, Z, anything. You can create anything. Okay. So it's a basically variable name. But if you're creating the any variable, so please use this particular variable throughout the session. Okay. Right. And after that, after that, we just use this head function to just check our all the details here inside the data. Okay. And with help of the sales function, we are getting this value, what is the number of rows and column. Okay. And with help of this describe function, we are getting the all the information about the all the statistical information. All the statistical information about the data, like what is the count, mean, standard deviations, what is the all the things, right? And and after that, you are going to use this count. Okay. You can also use a different column name and check what are the different value inside this particular column. Okay, so simply I just want to check how many patients are diabetic and non-diabetic, so we can check here with help of this count function, right? Okay, so till now everything is okay, sir. We can take the file. uh, we can take the file path in the read CSV of the data. Yes, yes, you can take the file name, but that time you have to change the you have to write the different code. Okay. So if you are going to use, if you are using the Google Colab, so you please follow this step. If anyone using the Jupyter notebook, so please upload the data set in your Jupyter notebook. Okay. Or if you're going to use if you're going to uh, putting the path name, so before the path name, you just write the R. Okay. So that time the code will be the different. Okay, so please follow the same step. Okay, there are several methods to upload the file. Okay, so please right now follow this each and every step so that we can complete this project, right? And yeah, I have corrected the file name, but showing the file not found error. Okay, So please, use the Google Colab and please follow this step, okay? And upload the file with help of this Google Colab code, okay? Because right now I'm unable to see your screen, so sorry, I cannot rectify. Okay, so please follow this step only, right? Okay, so after that, yeah. So till now we have counted all the value regarding the 0, 1. Okay, now we are going to you know we are trying to find out the x and y. Okay, so x is the basically x is the basically your features and y is the basically your target. Okay, so we are going to separating the data into the label and feature. Okay, so I'm simply defining here x as a feature. Okay, so I'm writing here x as a variable. This is a variable name and putting the data frame name. Fine. And this time going to use this drop column. This is the drop function, right? So what is the meaning of this drop? If you're going to write the drop function, so this drop function will just just delete that particular column. Okay. So in this x, I'm simply writing here drop. Okay. I'm just writing here the columns. Okay. Right. So you can see this solution. So I am going to select this column as equal to, and I'm putting here. Okay, I'm putting the name here outcome. Okay, and after that I'm writing here the axis is equal to 1. Okay, what is the meaning of that? So if you check here, okay, so these are the your different columns. Okay, so we have to select the features and target. Feature is it means we have to select the what we have to select all the parameters that are suitable for the features. Okay, so I'm selecting all the columns. Okay, so if I drop this column, so rest of the column will be the feature. So that then we will consider all the column as a feature. So simply I'm dropping these columns, okay, from this data set, so that the rest of the column will be considered as the you know x. Okay, x is a basically feature, right? And the for the y, okay, I'm simply writing here the diabetic, that is the database name. Okay, and this time I'm not going to drop anything. I'm simply writing here because we have only one target column, so simply I'm writing here outcome. Okay, so in this in the from the x we are dropping the outcome, because if we are dropping the outcome, rest of the column will be feature, and in the y I'm simply writing the outcome. Okay, so we have created the x and y. Okay, I'm going to run this program. So this time we are getting no error, right? Okay, so we have dropped the column in the x. Okay, so we have this kind of features, and this will be your output. Okay, fine. So I want to check again. Just I want to check this thing. Okay, what is the x and what is y now? Okay, previously we have the data, we have a data frame right now, but we recently we have dropped the x and y, we have dropped the outcome, and we have just taken the outcome. Okay, so now we are going to print the x and y. Okay, so I'm simply writing here the print x. Okay, so you can also check this is the case sensitive language. Okay, if you are defining here as a capital X, so please use the capital X in the next line of code. Okay, otherwise this it will throw the error because it's a case sensitive language, right? So you simply write here print X, right? So you can see here. Okay, so in this X column, in this feature column, there is no outcome. There is a no outcome column. Okay, because we have already dropped that particular column name. Okay, and after that we are going to print the y. Okay, now we are going to print the y. Okay, so you can just simply write here print y. Okay, so this time we are getting all the output. Okay, so this is your print y. Okay, and this your x. Okay. Okay, fine. So there is no error. I think there is no any query till now. Okay. Now we are going to apply the. We are going to perform the standardization of data. Okay. How can we just standardize the data? So for a standardization of data, we are going to use the standard scalar. Okay. So you simply define here. I'm going to defining here the scalar. Okay. I'm putting the function as a because we have already imported the standard scalar library. Okay, so simply I'm copying these things from the here. Okay, this is our function. So I'm simply copying this function in here. Okay, and I am putting here as a scalar as a function, right? Okay, right. Okay, and after that, after that, I'm going to standardize the data of the x. Okay, so simply you just write the scalar, and this time I'm going to fit this x value in the this standard scalar function. Okay, because we have defined this standard scalar as a scalar, so that's why we're using the scalar as a variable and using the fit function. And this in the fit function we are going to put this value as a x. So if x is a basically features. Okay, x is a basically features. Okay, right? So we have completed this standard scalar things. Okay. So after that, we are going to just going to transform the x. Okay. So you simply write here. Okay. A standardized data. So simply I'm going to writing here standardize the data. Okay. And we are writing here the scalar dot transform. Okay. Okay. So you can see here, this is a suggestion by the Google Colab. Okay, so simply I'm writing that a scalar dot transform. I'm putting here the capital S, right? So this is the solution. Okay, fine. So this time we are getting the no error. Okay. So now we are going to print this standard data. Okay. So because we have defined this variable name, so simply I'm going to print this variable. Okay. So we are printing here the stride data, right? Okay. So now we are going to check here. So we have extracted all the data of the features, right? Okay. After that, we are going to next time we are going to use this all the standardized data as x and y. Okay. So simply simply I'm going to declare here x as a standardized data. Okay. So simply I'm writing here x is equal to simply I'm copy these things standardized data. Okay, as a x. Okay, and y is the your this outcome. So simply I'm copying this data from here. Where is that part? Y. Okay. Okay. What is the need of a standard scalar? Okay. So basically, it's basically eliminating the mean from the feature, okay, and scaling them to the unit variance, okay, so that we can achieve the highest accuracy. That's why we are trying to perform this standard scalar. If you just take the formula of if you're interested to know about what is the mathematical intuition behind the standard scalar, so there is a one formula that is called z equal to x minus mu divided by s. So where mu is the training feature of mean, okay, and s is the standard deviation, okay. So with help of that, we can calculate the we can standardize the data, okay, so that we can achieve the we can achieve the unit variance, okay, for getting the highest accuracy, maximum accuracy, so that we can standardize the data, right? So now we are going to print the x and y. So simply I'm writing here print x, okay, and print y. Okay. So now we are getting this value. Okay. Although we are getting the all the X and Y value. Okay, fine. Okay, fine. Now we are going to, we have standardized the data. Okay. Now we have to perform the split of data into the training data and test data. Okay. Is there any, problem in, is there any query till now? Yes, sir. Can you please show the code of previous to this line? Okay. Yes, yes, Ravi Krishna. Yeah, please tell me what is the error? Previous program. Okay, fine. So you can check here. This is the previous program. Okay. Yes. So here we define the X as a diabetic underscore data. Okay. And Y is the outcome. Okay. So in the X we drop the columns, right? And in the Y we are just in the Y we are using the outcome as a column, right? Okay. And after that we are going to perform the standard scalar. Okay. So you are simply writing the 3 lines of code for the standardize the data. Okay. So because in the, if you see here, we have already imported this library in the pre-processing part. Okay. That scalar and pre-processing import the standard scalar. Okay. So simply right now we are going to, with half of this standard scalar, we are going to standardize the data. Okay. So simply I'm writing here, simply I'm defining the one variable as a scalar, and after that we are going to perform the standard scalar function, and then we are going to fit, we are just putting the X in the fit of, we are going to use the fit function to perform this standardization of data. Okay. And now we are going to perform the, now we are going to transform the data, transform the all the features value, right? So we are getting these things. Okay. Now we will use the X as our standardized data and Y is the diabetic data, right? Okay, so we got the all the value of X and Y, right? Okay. So now we are going to split the data into the trained data and test data. Please show me the code of X and Y. Yeah, sure. So you can check here. This is the X and Y. Okay. This is the X and Y. Okay. Okay, fine. Now we are going to train and split the data. Okay. So how can we just split the data? So we have X and Y. Okay. So we have to split the data X. We have to split the X into the train X and test X. Simply we have to split the data into the Y train and Y test. Okay. And then we perform. Then we will just apply the random state. Okay. For the shuffling of data, and we have to also take the test site. Okay. So we will use 20% as a test site. Okay. So how can we write the code? Okay. So and this you can see here in the starting we have already imported the one library for the splitting of data. So sklearn dot model underscore selection import train underscore split. So we will use this function train underscore test underscore split to splitting the data. Okay. If you're not importing this library, so we cannot split the data, right? So it's the very essential library. So with help of this library, we are going to split the data. Fine. So simply write here X underscore. Okay. Write the train. Okay. Then you just write X underscore test. Okay. Y underscore train. Y underscore test. Okay. Then you just write train underscore test. Okay. Underscore split. Okay. We have already defined that particular function. If you check the library, Skill-Lync pre-processing library, so we have already defined the train underscore test underscore split function, right? So in this function, we are writing defining here X comma Y. Okay. And writing the here we are defining here the text underscore size, was it? Okay, is equal to 0.2. So what is the meaning of 0.2? Okay, so basically 0 point is nothing but it's a 20%. Okay, so 20 by 100. If you are going to divide if you are going to divide 20 with 100, so your output will be 0.2. So simply I'm writing here 0.2 as a 20%. Okay, so you can also use the 0.3. That time your value will be different. That time your accuracy value will be different. So it's depend on you. Okay, if you want to make a very good model, so that time you try to split the try to split the data into 80% and 20%. Okay, that time you get the very good result. Okay. Okay, then you just define after that you can just define the random state. Okay, before random state you can define one things. Okay, we can define a state file as a y. Okay, just a minute. Y should be capital. Okay, then you define the random state. So you simply write the random underscore state. Okay, so you can, in place of random state is equal to 2, you can use the 20 or 100. It will not reflect any change in your value. Okay, it's basically trying to shuffle your data. Okay, that time if you're using 80% and 20% data, so which 20% data will be considered as test data? It will be not clear. We can each and every time we will shuffle our 20% and 80%. Okay, so there is no, we are not going to divide. This is only 20% and this is only 80%. We can shuffle each and every we will shuffle the complete data set, and in this shuffle part we will use any 20% as a test data or any 80% as a training data, right? Okay. Okay, fine. So this time getting the error. Okay, so this. Okay, yeah, so that's a spelling mistake here. So if you check the random state, so spelling of random is a there is wrong spelling in random state. So that's why it's a throwing error. So first we correct the spelling. Okay, so this time we are getting the not error. This time we're getting not any type of error. Okay. Yes. So what is the yes random spelling? Thank you, Sivani. Yeah. Yeah. So we have just rectified this spelling. Okay. Now it's fine. Okay. Now we are going to. So we have splitted the data, training data and test data. Okay. Now we are going to check the what is the shape of X train and Y train. Okay. So how can we check the shape? So this time you simply that time you simply write print X dot shape. Okay. Then you just write X underscore train dot shape. Okay. Then you write X underscore test dot shape, right? You simply write like this. Okay. Okay, so this is the shape of X train and X test. Okay, so we have splitted the data into the this is the this is the current X shape. X 768 is the before splitting the data. After the splitting the data, this is the X train and this is the X test. Okay, so 614 is the X train and 154 is the text length. Okay, yes. Avni, getting the value error, too much value is unpacked. So why you are getting this kind of, okay, I think Avni, you have missed the standardization of data. That's why getting you error. So please perform this task. Okay, if you are not going to standardize your data, so definitely you get this kind of error. Okay, so you perform this 3 step. Use the standard scalar. You use this scalar dot fit, and then you standardize the data. Okay, if you perform 3 tasks, okay, after that you will not get any error. So please check and confirm, have you performed this task? Okay, if you perform this task, so yes, I have done. Okay, then why you are getting the error? Can you just try, can you just take this any spelling, or you can just take the train you can check the this time there will be a chance you have defined the X train as a capital or small. Okay, in the Y train there will be capital and small. So you please check the correct like if you are using the any uppercase, so please use the uppercase. If you are going to use any lowercase, so please use the lowercase. Okay, otherwise your interpreter will throw some error. Okay, what is the use of okay, Yes. So Shivani, random state na basically it's the this time you basically use for the shuffling of data. Okay, like you're going to if you're going to divide the data. Okay, if you're going to split the data, so who will just define what part of data will consider as the training data and what part of data will consider test data. Okay, so we can randomly decide that. Okay, so that's why you are going to that time you're going to use this random state, right? Okay, and this is used for to generate a training and validation data split. Okay, so it's a use the same percentage of classes in each split. Okay, that's why we just use the these things. Okay, for the for the same percentage of classes in each split. Okay, so that's why you're using this randomization and these things. Okay, fine. Okay, any other queries? Okay, fine. So after that, so this training, the training and this, yes. Okay, fine. Yeah, cool. So yeah, now we have finished this part, training part and test part. Okay, you know, this time we are going to train our model. Okay, so I'm simply writing here the text, training the model. Okay.
Hey, sorry to interrupt, Saurabh. So, guys, just to confirm that are you guys able to follow the things and things are going well? If yes, just type in the chat box yes, and if no, then type in the chat box no, so that we can understand if the things are going in the good direction. Awesome. Thanks, Ananya. Thanks, Sankadeep. Thanks, Larry. Thanks, Arjun, Balraj, Madhusudan. Awesome. Great, guys. So great. So the thing is, the reason we have I have asked this question is like, if any a struggle you're facing, or if you're feeling that speed is a little bit what we say pace at which the workshop is going is a little bit fast, feel free to let us know. But I think thanks Shipra, Priyadarshan, Shivani, right, Ashish. So great, guys. So thank you so much for the response. And yeah, thank you so much. So yeah, sort of you can take it over.
Okay, fine. Yeah. Okay. So yes. So now we are going to train the model. Okay. So for the training the model, we this time we are going to use this SVM. Okay, so SVM is called support vector machine. Okay, so we will explain later like what is the different mathematical intuition behind this SVM. Okay, so simply we are going to write we are going to writing the code. Okay, like how can we just define the SVM. Okay, so basically, support vector machine is the supervised machine learning algorithm, and that is used for the classification as well as regression problem. Okay. So classification, it means categorical target data, and regression is for the continuous target data. Okay. So this we can use this SPM in the both cases, right? So the goal of this SPM algorithm is to create the best fit, best line or decision boundary that can generate the n-dimensional space into the classes, so that we can easily put the new data into the correct category. Okay, so that's called the decision boundary. Okay, and this decision boundary is sometimes also called a hyperplane. Okay, so this in this algorithm we are going to just going to build the like SVM. Okay, so how can we just build the this machine learning model? So simply I'm going to just writing here the classifier and declaring the one variable as a classifier. Okay, so if you check here, okay, so you can check here. Yeah, so we have imported one library, that is the sklearn import SVM. Okay, So we will only use this library for building the machine learning model. Okay. So this time, I'm going to declare one variable, that is the name of the variable is a classifier. Okay. Okay. Yeah. Just a minute. Classifier. Okay. Yeah. Right. And we have defined SVM as a SVC. Okay. So simply I'm writing here SVM. Okay. And this write SVC in the capital. Okay. That is called support vector classifier. Okay. So we have to write in the capital, because it's, we can also check here if you're writing in the small. So that time your suggestion will be Google Colab give you the one suggestion. Please write in the capital. Okay. So simply write in capital. And there is a one method. Okay. So there is a several method for the implementing the this SVM. So simply I'm writing here the one method is that we have to define the kernel. Okay. So if you're writing the this thing, so you can check here. They will also give some suggestion. Okay, that is called the auto suggestion. So simply in the kernel we have to define the kernel. If you're writing in the column, so that time you can see it will right now it's not showing any auto suggestion. So but it will generally suggest the auto suggestion. So simply we are going to define here as a linear. Okay, so kernel will be your linear. Okay, so I will explain later why you are going to use the linear here and what are the different things we can use here. Okay, so simply right now we are going to use this kernel as a linear, right? And after that we are going to train the we are going to train our data with help of support vector machine. So how can we do that? Okay, so so we have defined here the classifier. Okay, so please run this code. Okay, first we run this code. Okay, so there is no error. Okay, so it's working fine, right? So we define this variable classifier as a variable. Okay, so for training the data, we will write here. Okay, so I'm just try to copy this class this variable name. Okay, so simply you just write the classifier and then use the fit function. Okay, that is the fit function. In the fit function, we will write xtrain. Okay, because we are going to train our model with, first we will train our model on the training data, right? So simply I'm writing here xtrain and ytrain. Okay, right? Okay, fine. So it's working fine. So we are getting the so now we trained our model with help of this support vector classifier, right? Okay, now now we are going to this time we are going to check the accuracy of the score of training data. Okay, so this part is completed. Okay, this is a very simple algorithm, so this part is completed. Okay, now we are going to check the accuracy score of, that is called the model evaluation. Okay, so it's saying here it's the model is defined, that is the SVC, and the kernel is linear. It's define the model. Okay, so how can we evaluate our model? Okay, so with help of this accuracy score, we can evaluate our model, right? So yeah, any queries? Sir, why SVM? Why not the other algorithm? Yeah, we can use any algorithm. So basically, this is the one kind of classification algorithm. Okay, we can also use the logistic regression. Okay, we can use the any one algorithm. Okay, so first we try to build the web app application with one algorithm. Okay, after that I will explain each and every algorithm. Okay, we can use the multiple algorithm at a time. Okay, the only thing is matter accuracy. Okay, why you are going to use the different algorithms, because we want to achieve the highest accuracy. Okay, why you are going to use the number of cores in the CPU, like quad core, 8 core, because we want to use the we want to utilization of 100% CPU. Okay, so only thing matter is the accuracy, right? So that's why, yeah, how to find which algorithm is good for the kind of problem. It's depend on the modeler. Okay, so for the accuracy, for finding the accuracy, it's not depend on the algorithm. It's depend on the data cleaning. Okay, it's depend on the feature selections. It depend on the your targets value. Okay, so based on that things, so you depend the all the part. Okay, so if you're not performing the data cleaning, you are not going to standardize the data, so you cannot got the 100% accuracy or like more than 90% accuracy. Okay, so simply if model is providing the 75% accuracy, so that time we call that this model is good. Okay, yes, hope you got the your question. Hope you got the answer of your particular question, right, Ajay? Sir, we want to know use of algorithm, why you're using a particular diabetes data set. Okay, fine. So, we can, Shivani, you can use any data set. It's not a matter of diabetes data set. Our task is like, I have already disclosed one flow chart, one that is called uh, flow chart, that is called like what is the life cycle of any machine learning model. Okay, so the task is like how gather the data. Suppose we got the any data. Okay, we got the like data, so then we will check that this particular data is categorical data, continuous data, label data, unlabeled data, structured data, unstructured data. So see, there are several types of data. Okay, based on that we have to, we have to select the algorithms, okay, from the supervised and unsupervised machine learning. Then we can apply this machine learning model. Okay, fine. Okay, so yeah, so now we are going to test the accuracy score. Okay, so how can we how can we just calculate the accuracy? So simply we just write here, I'm going to define here the x trend underscore trend. Okay, right, I'm simply writing here the prediction. Okay, and writing here the classifier, because we always this time we will always use the classifier. Okay, if you see this kind of if you're going to see the classifier keyword, so please try to understand in this classifier is only variable that represent the support vector machine. Okay, so after that we will use the classifier several times. Okay, so please keep this word in your mind as classifier. Okay, that will reflect the SVM. So this time we are going to calculate that accuracy on the X-train prediction. Okay. So simply I'm writing here the classifier. Okay. Classifier. Okay. Right. And then we write predict. Okay. We are going to predict on the X-train. Okay. We are going to predict on the training data only. Okay. So simply I'm writing here the X-train. Right. Okay. And then after that we are going to I'm going to write here the training data underscore accuracy. Okay, accuracy. Okay, here I'm going to write the accuracy score. Okay, that is accuracy. So what is the accuracy score? So come to this library. Okay, so this is the accuracy score. So this is basically one function, and this particular function is available in this particular library, Skill-Lync.matrix, right? So this is a particular function. That's why I'm using here accuracy score. Okay, right? Okay, then here I'm writing here X trend. Then we are going to writing here the X trend prediction. Simply and copy this thing from the here. Okay, and the Y trend. Okay, now we are going to run these things. Okay, so please. Okay, fine. So there is no error. Okay, so now we can simply write the print statement. So we can print the training data accuracy. Okay, so simply I'm writing here the print. Okay, and here I'm going to print this part, training data accuracy. Okay, so you can check here, it's showing 78%. Okay, so now let's print this part. Okay, 78%, or you have to check the ones. Okay, yeah, so it's giving the 78% accuracy. Okay, so this particular model is this particular SVM model providing the accuracy on training data is 78%. Okay, now we are going for the test data. So this we have performed this accuracy check on the test training data only. Okay, now we are going to write the same thing on the test data. Okay, so how can we write this test data? So simply you copy here. Okay, so you just copy these things here. Okay, so I'm just going to copy these things, all the code. Okay, so in place of train, you just write the test. Okay, so in place of train, you simply write the test. Okay, test prediction, x test, test. Simply you just write here accuracy test x. Simply you write here. That is fine. Simply here write you test. Okay, and here you just write the test. Okay, and now you run this thing. Okay, and also trying to copy this thing in place of. Okay, so this time you're going to use the training data, sorry, test data. Okay, so in place of training here, you can also write the test data accuracy, right? So now run this code again and also run these things. Okay, so on the test data, we are getting 77% accuracy. Okay, so on the training data, we are getting the 78% accuracy, but on the test data, we are getting 77% accuracy. Okay, so that's the fine. Okay, not a big deal. Okay, okay, now we are going to make the predictive system. Okay, that's a very important. Okay, how can you make the predictive system? It means, simply we are, this is we are this all the things we are getting on the training data and test data. Simply I just want to put the all the values. Suppose this is a please open your .csv file. Okay, so in the csv file, suppose you are saying that the pregnancy is 10, glucose is 110, 110. Okay, and the blood pressure is 92, and skin thickness is this much, BMI is this much, diabetes is this, and age is this. So can you predict what is the outcome? What is the this is the particular person is diabetic or not diabetic? So how can we do that? So with help of with help of this prediction system, we can do that. Okay, so how can we make this predictive system? So simply we will take one value. Okay, so this time we are going to make one. So it's the only with help of only two to three lines of code we can do that. Okay, so this time, I'm taking the one input data. Okay, so you can take any input data. Okay, so from the your CSV file. Okay, you can only take the input data. I'm simply writing here. Okay, that is the, yeah, any other queries? Yeah, please. How to classify data is labeled or not? Okay, okay, fine. Yeah, so based on you, if there is any target, Preeti, your question is fine. If there is any feature and target, that if in this particular data set, diabetic data set, so we have a feature, and based on that feature, there is an output column. That output column represents the patient has diabetic or not. Okay, so here the output is your target column. If there is any feature and target, so that time we call the data as a labeled data. If there is no output column, there is no target column, so that time your data is called as unlabeled data. That is your that is fine question. Okay, that is okay. Yes, any other queries? Yes, Sai Kumar, I'm not getting your question. So can you write your question? Okay. Okay, fine. So this time I'm going to take the input data from the file. Okay. So please open your file, CSV file. Okay. So please open your CSV file. Okay. And this time creating one tuple. I'm taking the values. Okay. So 5 is basically value from the pregnancy. Okay. I'm taking the another value from the another columns. Okay. Simply I'm taking the one value 72 with the column name as the blood pressure. Okay. You can select any value from the data data set. Okay, 19. This 19 value is from this is from insulin. Okay, and simply you're taking all the value from the data set. Okay, select the one row value. Okay, don't select select one value from this column and select this value from another column. So you simply just enter the 1% data. So this all the data, this all the parameters belong to one person. Okay, that's fine. So I'm selecting here the body mass index is 25.8. Okay, and another value is the 0.57587, right? Okay, okay, right. So I'm taking this value, right? And after that, I'm going to I'm just taking the input data, right? And changing all the data, I'm going to change all the input data into the NumPy array. Okay, so how can we change all the data into NumPy array? Okay, because we have to also standardize the data, and we have to put all the data in the form of array so that our classifier can. Classifier is basically our SVM model, so that our classifier can identify the data, because we have already standardized the data. We are not giving this data. We have already standardized the data. Okay. After that, we are giving to the model. That after that model, we are predicting something. Okay. So we have to make the predictive system. So we have to also the enter the value in the form of NP array. Okay. So simply I'm changing the input data into the NumPy array. Okay. So simply I'm writing here input. Okay. Underscore data underscore as NumPy array. Okay, right? NumPy underscore array, right? Then I just input NumPy array. Okay, fine. And then I just use NP is a basically NumPy is a basically NP. Okay, so simply I'm typing NP as array. Simply I'm writing here NP as array, right? And inside this array, I'm taking the input value. So this value, input data, I'm taking the input value, right? Yes, right. After that, we are going to reshape the array, as well as we are going to predict for one instance. Okay, so how can we reshape that? Okay, with help of reshape function. So this time I'm writing here input underscore data underscore reshaped, right? And I'm putting here input underscore data as NumPy. As a NumPy array, fine. So this is auto suggestion, that's good. Okay. Now we are going to we are going to use the reshape. Okay. So I'm taking a resetting the data as 1 minus 1. Okay. After that, we have to standardize the data, because we can only provide the data to a classifier in the form of unit variance. Okay. So how can we standardize the data? Simply I'm putting here a standardized, that is the standard data, right? So you can see here there is the standardized data. So I'm not writing the complete things. I'm try to declare the one variable as standard. Okay. Now we are going to writing here scalar dot transform. Okay. And this time I'm getting this time in the transform I will enter these things. Okay. This because we have received the data. So this time we are going to use receive this uh, inside this function. We are going to use the input underscore data and this receive. Okay. So this time we are getting this value, right? And after that, we are going to print the standardized data, right? Print standardized data, right? Okay. Yes. Okay. You can also run this code, but I'm right now not going to run this code. So this time we are going to going for the prediction part. Okay. So for the prediction, I am writing here for the prediction things. We have to predict the particular person is diabetic or not. Okay. So simply I'm just writing here the prediction. Okay. Prediction, right? So in these predictions, we are writing here classifier. Classifier is basically our model name. Okay. Classifier. Okay. So this is auto suggestions classifier. Okay. In this classifier, I'm writing the predict. Okay. So how can we predict that from this standardized data? Because we have a standardized data. Okay. So simply I putting here as a standardized data, right? Okay. And then we are putting the one conditions. Okay. Inside these things, we are going to putting one condition. If the prediction is 0, so that time the person is not diabetic. Okay. If there is 1, so the person will be diabetic. Okay. So simply I'm writing the if loop. Okay. If else condition, not a loop. Sorry. So simply writing the condition here, prediction, prediction, you know. So in the prediction, I'm putting the value as a 0. So that is a 0, fine. Is equal to 0. So it means the prediction value, is the prediction value is equal to 0. So that time we have to, that time it will predict the, that time it will predict the, so simply I'm writing the here print. So that time it will predict here, the person is not diabetic. Okay. The person is not diabetic. Okay. And the else condition, okay, right? Simply I'm writing here print, the person is diabetic. Right? Okay. So now we are going to run this code. Okay. Let's see if there will be any error. So that time we have to rectify that error. Okay. So this time we are getting the error. Okay. So here is the error. Okay. So I think there is some indentation error. Okay. So just a minute, predictions value. Okay, fine. So only getting the indentation error here. Okay. So let me just clarify this error. Yes, any other question? Yeah. So yeah, decrease the indentation before else. Yeah, I'm also trying to do that, but unable to confirm. Yeah. So this time, sorry, just a minute. Okay, fine. Okay. So I think there was some error. Okay. So right now it's working fine. Okay. Yes. So you can check here. I think there is some indentation problem. Okay. So that's why it's showing error. Okay, fine. So you can check here. I'm simply writing the same code. Okay. So simply I'm just also commenting this array. Okay. So this value simply I'm writing here. Okay. So error was only the spaces here. Okay. So I just missed that particular spaces. So if you just select here, okay. So this time, I'm taking the value here. Okay. That is the input value. Okay. So I'm taking the input value, I'm changing the data. Okay, you can select any value. Okay, so it's not a big deal. Okay, you can select, you can also check the any value. Okay, and you take the input, you can just change the input data into the numpy array. So simply you just write np dot as array. Okay, right? Then we just reshape the arrays. We are going to predict one instance. Okay, and then we just then you just print the classifier. Okay, they simply you just write the prediction equal to classifier dot predict and take the input underscore data receipt, right? And then we just print the predictions. Okay, so if you're going to if you're just getting the prediction is equal to 0, so that time it will print the person is not diabetic. If otherwise it will predict the this is a diabetic, right? Yes, Dipanshu, yeah, yeah. This is the exact error. Okay, this is fine. Okay, so can anyone just tell me till now is there any error? Till now is there any problem in particular code? Okay, after that we are going to build the build the web app. Okay, that's a very important thing. Okay, so till now is there any problem for building this machine learning model? Okay, fine, right. Sir, can you paste the code here? Sure, sure. Okay. So you can just take this code. Okay. I'm just you can also write the code here. It will be better. You can just write the code. Okay. Once show the entire code. Okay, fine. Yeah. So I will try to explain the code once again. Okay. So you can simply write simply you just import the essential Python library like NumPy, Pandas, sklearn. Okay. Sklearn preprocessing, I import a standard scalar. Then you just perform the model selection and import the train underscore test underscore split. Okay. And then you just import the SVM. And we are going to just import the sklearn dot matrix, import the accuracy score, right? And then we are going to just write this from import just uploading the data from google.colab import file. Then we can upload the things. Okay, and after that we are going to just going to create the data frame. Okay, then we are going to just check the what is the shape of data frame, and with help of this describe function we try to find out the statistical values of this data set, right? Okay, then we are going to just check whether the what is the features and what is the target column. Okay, okay, yeah, one last line of code. Okay, fine. So you can check here the last line of code is the this one. Okay, this basically this is called the predictive system. Okay, so we can simply you can simply giving the value on the our that classifier. So classifier is basically our SVM support vector machine. So we can with help of this value you can check you can take the any value from the data set. Okay, so if you are going to change the value, this predictive system will be give you the exact value, right? So you can check, you can also try it. Okay, you take the different input value and you can just try it, right? Okay, so the important thing is that now we have to save the model. Okay, for the deployment of model. Okay, so for the deployment of model, we have to save the push code. Okay. So how can we save the code? Okay. So we cannot save the directly, because if you are going to save the directly code, so that time we will get the only value in the form of .ipynb file format. So basically .ipynb file extension is the Jupyter notebook extension. Okay. So you can check here. I've already saved this file. So you can see here this is a Skill-Lync.ipynb file. So basically, this is the one Jupyter notebook, right? Nothing else. Okay, but we have to save this file. Okay, so how can we save this file? So for saving this training model, okay, for saving this training model file, we have to import this one library. Okay, so there is one library. Yeah, the name of the library is the pickles. Okay, so pickles, okay, pickles is used for serialization and visualization in the Python object structure. Okay, so you can it's just converting the Python object into the byte stream to store the file or database. Okay, so we have to convert into the object into the byte stream. Okay, for the deployment of a model. Okay, so how can we do that? So we have to write like this. Okay, so simply you just write import pickles. So please follow the same step. Okay, it will be this after this difficulty level will be high. Okay, so till now the difficulty level is like easy. Okay, this time we are going to install two libraries or more, and then we will start coding with the spider. Okay, so from here the very this is the important thing. Till now, from data to just training a model, that part is very easy. From here, please be with me. Okay, if you have any doubts, so please write in the comment. Okay, so from here we are going to just first we will write the pickle. Okay, first we will import the pickle, right? Okay, so there is no error. Okay, then we will use then we will write here file name. Okay, okay, then we will write here the file name. Okay, so I'm here file name, I'm just writing here the train model. I'm writing here or trained underscore model. Okay, dot sav. Okay, so basically sav is the save file. If you are going to save the file, so the extension will be sav. If you are going to import the model, after that you are going to going to save your train model, so the extension will be sav, right? Okay, after that we have to save that file. So how can we just save the file? Okay, so we can save the file with help of dump function. So there is one function, the name of the function is dump, dump. Okay, so with help of dump function we can save the file in the pickle. Okay, so simply you just write pickle. Okay, so pickle is a library. Okay, simply you write dump. Okay, and this is a very important, the classifier. The classifier is like, you have created the one model, SVM model, that is the classifier. So spelling is, you check also, you can also check the spelling. Fire. Okay, fine. Then you have to just open this thing. So you have to open this file. So you just write the open. Okay, and then you have to put the file name. Okay, and here we have to write this WB. Okay, for the writing the binary code, so we have to write the WB. For the reading the binary byte code, that is a binary code, so we have to write the RB. So here we will use, first we will write the WB, after that we will for the loading the model, that time we will write the RB, right? So let me run this code. Okay, okay, fine. So there is no error. Okay, that's good. Okay, so after that we will load the same model. Okay, so how can we load the same model? Simply you just write loaded underscore model, right? And then you just write pickle dot load, right? Then you just write open. Inside the open, you just copy these things because this is your file name. So you just copy this thing and inside this single quotes you put here. Okay, and then you just write here RB. Okay, for the reading of file. Okay, we are going to read here, that is by writing the binary code. Okay, writing the binary format. Okay, so let's run this code. Spelling is pickle is okay, so there is some spelling mistake here. Okay, so the pickle is right. Okay, fine. So now we are going to run this code. Okay, now it's fine. Okay, so we have saved the file successfully. Okay, so how can you check and where is the file? How can we check that? So simply you click here. Okay, are you able to see this part? There is one icon, suitcase like icon, that is folder like option icon. So click on that file and you can click, you can download this file. Okay, so this is your trained model. This is your train model because we have saved the file with a train model. Okay, so that is the train model. So please download this file because this now in the for the creating the web applications. So we will not use this Jupyter Colab file. We will not use this IPYMB file. We will only use this train models.sav file. Okay, So now just forget about this whole file. The whole file is converted into binary format. So we will use this train underscore model dot sav. Okay. So there is no need to write the whole line of code in the spider. We will only just copy this file and put the location, because all the information is stored in the format of binary, right? Okay. Any question? Are you getting? Like, are you able to are you able to get this file train model dot csv? Please confirm in the chat box. So after that, we will write the code in the spider. Everyone got this train underscore model dot sav? Okay, fine. Okay, fine. And please open the Anaconda. Please, everyone, open the Anaconda navigator. So if you have already installed the Anaconda, so please go to the search icon of your desktop or laptop and just write Anaconda navigator. Okay. Simply write Anaconda navigator and please open the Anaconda navigator. After that, you just open the spider. First, you click the Anaconda, and inside the Anaconda IDE, there will be one icon, a spider. Okay, there will be symbol of a spider. So please check the icon like spider, and please click on the launch button. So there should be one launch button. So please click on the launch button. Okay, then we will start coding on spider. Okay, and with help of spider we can develop a web app. Okay, right? Okay, so please everyone open this thing. Okay, so we have saved all the file. Okay, so if you want to again like if you are like if you want to see like how can we save the file with train model, how can we just give the output of this the complete algorithms. Okay, so if you want to validation of all the things, no, so you can simply just copy these things. Okay, again I am going to copy the whole information, and I'm going to putting in this saved file model and train underscore models are saved. Okay, I'm going to these things. So in place of classifier, because there is no more classifier, because we all the classifier and all the code is now converted in this train model at the sav. So in place of classifier, you simply write this thing. Okay, so load in place of classifier, not the these things. Yes, so in place of classifier you just write the loaded model. Okay, that thing, this you just write the loaded model. Okay, and now you run this code. Okay, so so there is no need of this line of code. Okay, so from the last 2 hours we have written few lines of code, so now there is no need of this, all this code. So all the code we have converted this into the train underscore model dot sav. Okay, so train underscore model dot sav is our the file name. It will be the file name that contained all the information about our algorithms. Okay, all the information our classifier. Okay, because if you can see here, if you're going to write these things, okay, in place of classifier I'm simply writing the loaded the model, so we can this time we are getting the same output. This particular person is diabetic. Okay, so please confirm, please we check the code. Okay, please you can also try this same thing with the code. Okay, please. Okay, and please open your spider. No, okay, so now we are going to write a code on a spider. Okay, so right now I'm going to share my spider screen. Okay, so please uh, open your spider screen. Yeah, so this is my spider screen. Okay, so this is the screen. Okay, so everyone please open this kind of screen. You can see here, this is the spider python 3.9. so please open everyone the spider file. Yes, Dixita, yeah, please tell me what is the query. Dixita, yeah, please tell me. You can write your question in chat box. And please confirm, are you able to open your Spider notebook? Please write in the chat box. Are you able to see my screen, Spider screen, and are you able to open the Spider notebook? So please write in the chat box. Everyone, please write in the chat box. Yes. So we are on the same page, right? Okay, fine. Yeah. So yeah, Lahari is Sankalita. Yeah, everyone. Okay, fine. Yes, please, everyone, write in this chat box. Okay, fine. Arjun, Omkara, Balraj. Okay, fine. Sankalita, Sen Gupta. Yeah, everyone, fine. Okay. Wow. Where will be the saved data? Okay, okay, fine. Okay, temp file is here, not temp file. Okay, you can for the just a minute. I'm trying to stop my screen. Yeah, please, you can, yes. So you can download the save file from here. Okay. So please click on this icon. This is icon name is folder icon. So click on the folder icon. This folder icon will present in this particular icon is will available in the left hand side. Okay. So please check that icon. Sir, it's not there. Okay. If there is not, so you can check your code. Okay. I think there is will be mistake on your code. Yes, yes, you can deploy through the Flask also. Okay. So you can also use the Flask. Okay, there are several things we can do that. Okay, but we are going for the easiest way. Okay, so with help of Streamlit, we can do that. Yeah, Flask we can use, definitely we can use it. Okay, yeah. So okay, fine. Yes. So please open. Everyone come to the spider part. Okay, because we have to complete this part. Okay. Okay, fine. Okay, so in this spider, okay, so we have to write few lines of code for the deployment of for the making of this web application. Okay, so simply simply we will write here. First we will write the import. Okay, so first we have to import this numpy. Okay, first you write the numpy as np, right? Then you write the import pickles. Okay, you have to write the import pickles. Okay, and after that we have to import this library called Streamlit as st. Okay, so these are the three mandatory libraries. So please everyone, this please write this library and please run these things on your spider. Which one is easy and efficient to use the Flask or using a spider? You can use anything. Okay, so not a matter of efficient. If you want to, it's a matter of graphical user interface. Okay, because we have already created our model. We are only part is we have to create a graphical user interface. Okay, so with help of Streamlit, it will be easy to create one graphical user interface. Okay, so we just want to create one graphical user interface in our local host. First we will create in the local host, and after that there are several cloud services. Okay, with help of this proc file, a requirement file, and this two file, you can deploy on a model in any cloud. A few months back, till November, there was one famous Heroku platform that is a free of that time that this platform was free of cost, but right now it's paid. Okay, so there are several free platform also. You can also deploy with help of this two this 4 5. Prop file, text file contain the all information about your libraries. But this to file is very important. But first thing, our first task is we have to create this web-like application on a local host. Okay. If you are able to run all the this kind of application in a local host, so you can with help of few lines of code, you can first you import all the file in Git. Okay, in a Git profile. After that, you can deploy on a cloud. Okay, so free. There are several free cloud like Streamlit also there. So you can also play there. Okay. So sir, can you tell it once how to open? I got the file. Okay, okay, Dipsika. So Dipsika, you got the file. That is fine. Okay. So just download that particular train model file. Okay. Now you open your Anaconda notebook. Now you open the Anaconda IDE, and inside the Anaconda IDE there is there is a spider. Okay. So in the spider, you please open the spider notebook, and now you are going to now you are come to this code. Okay. Please write this all the information. Okay. Please write all the informations, all the code on this Jupyter or this is spider notebook. So yeah, please confirm like how many people have completed the Google Colab task, and they are working on and they are writing the code on the spider. Please confirm in this chat box. How many people are going to writing the code in the spider? Sir, yeah, it's showing Streamlit is not like available. It's fine. Okay, okay, okay. Yeah, it's Streamlit is not available, so you can just open the Anaconda navigator. Okay, and you just open the yes. How can you open the spider? Yeah, okay. You know, just a minute. Let me stop this screen. Okay. Yes. You know, you can you can so this is the Anaconda navigator. So first you open this thing, Anaconda navigator, and after that you just scroll down, okay, and this is a spider. Okay, then you click on the launch. Okay, then you click on the launch. Okay, if anyone getting the error like this particular module is not available, okay, so simply you can see, please see here, this is the Anaconda navigator. So please click on the environment, then you click on the base root. Okay, click on the base root, then you just run this base root. Okay, and click on the open terminal. Okay, so first click on the environment, click on the base root, and please open the terminal. And inside the terminal, okay, so inside the terminal, so this is your terminal. This is your terminal. Okay, so inside this terminal, please write the commands pip install Streamlit. Okay, simply simply you just write pip install, okay, Streamlit. I'm writing in the chat box. Okay, you simply write, because this is the essential library, so we have to install this all the library with help of pip install. Okay, so you can simply write with help of pip. Okay, pip install Streamlit. Okay, and for if you are anyone getting the pickles is not available, so you can also install this thing pip install pickle. Okay, pickle hyphen mix in. Okay, mix in. So this is one library, pip install pickle mix in. Okay, so please install this two library. We cannot see your terminal. Okay, are you able to see this terminal? So this is terminal. Okay, so how can you find out the terminal? So please click on the environment. Please click on the environment. Are you able to see this Anaconda navigator? Please write in the chat box. Or are you able to see my Anaconda navigator page? Yes. So please click on the environment, click on the base root, and after when you just click on the play button of base root, after that there will be this 4 icon. Okay, so please open the terminal. So click on the terminal. So inside this base root and inside this terminal, you have to install that two library. One is the Streamlit and another one is the pip install pickle hyphen mixin. Okay. So this is the very mandatory library. So you have to install it. Okay. So please do it as soon as possible. Okay. Okay, fine. Now, when you just finish this two tasks, after that you come to the spider part. Okay. Please run this two tasks. Okay. Pip install Streamlit and pip install pickles mixin. Okay. Uh, okay, so not the pips, you can simply write the pip. Okay. So please write inside the terminal. Shivani, you just write inside the terminal. And please confirm, have you finished this installation part? Pip installed uh, pickle mixin and pip installed Streamlit. Have you finished this task? Please confirm in this chat box. Yeah, that's a good debug rhythm. Yeah, that's great. Please confirm in chat box. If you have finished these two tasks, please write in yes in this chat box. Okay. After that, we will write a few codes inside the inside the spider, and then we can create a web application with help of this Streamlit library. Okay. So please write in this chat box. Okay. Any query, like if you're facing any error, so please also write in the chat box. Okay, so that we can continue this task. Okay, so please write in the chat box. Okay, fine. So after that, now we are going to load the save model. Okay. So we have to write the save model. Okay. So how can we load the save model? So simply we have to uh, we have to write the save model. Okay. And inside the save model, we have used this uh, we have to use this pickle. Okay. Pickle dot load. Okay. And inside this load function, we will open. Okay. We will open the file. So what is the file? File is the basically your location of saved model. Okay. So what is the file? So please let me check once what is the location here. Okay, fine. Okay. So yeah. So please inside this load model, please select your locations. Okay. Like anyone downloaded the safe this file. If anyone downloaded the this is the name train underscore model dot sav file. So you just put the you just select the location. Okay. Suppose I am just downloaded this file in the user desktop, and that in this desktop there is a folder like diabetic train underscore model. Okay. So I have downloaded this file in that particular place. Okay. So how can we just find out the how can we just find out this path? So for finding the path, simply we will open these things. Okay. Suppose this is a model. I have downloaded the model here. So simply go to here and click this one. Okay. So you can just click this, okay. Suppose I just clicked here, okay. So simply you just copy this link. So this will be the link, okay. And after that, you just put the one backslashes, okay, and put the backslash, okay, right. First you put the backslash, and after that you write the this name, model underscore trend underscore model dot sav, okay. So we have to give the location of this file, okay. Are you able to see my screen? Just a minute. Let me share my screen once. How can we just find out the location? Just a minute. Yes. So you can check. You can see here. Just I want to demonstrate how can we just find out the location. Okay. So simply you can check here. This is the file here. Okay. Mm, yes. So this is the file. Suppose I downloaded the file here. Okay. So simply you just copy this link. Okay. So we can select this path. Okay. So this is your path. So this is your complete path. C/user underscore Saurabh Ranjan plus desktop workshop Skill-Lync. Okay, this is your path. Okay, and after that you have to give the backslash. Okay, and then you just write the this trend slash model. Okay, so this will be your complete path. Okay, right. So this is will be complete path. So just you copy the path. Okay, and paste in the Jupyter in this spider notebook. Right. Okay. Yes, path not found. Okay. Uh, like please confirm, like how many participant has completed this task? Are you able to found it? Are you able to find the path? Please confirm in this chat box. Okay, fine. Yeah, that's great, Lahari. Okay. Okay. So when you just and you have to do one thing. Okay. So in this. Okay, so like in your path, you have written the all the path in the backslash. Okay, so if you're going to just copy the path in this if you're going to copy this path in the desktop, so that time your slash will be different. Okay, so please convert the your all slash into this slash. Okay, this forward slash. Okay, if you are just written in this backward slash, if you are going to written in a different slash, so just write in this way. Okay, so just we give the slash like this. Okay, because in the spider they will consider the only this kind of slash. Okay, so you have to write, I'm writing this chat box. So you have to write like this. Just a minute, I'm writing this chat box. So you give this slash only. Okay, so yeah, yes. Okay, so yeah, right, yeah, right, Dipanshu. Okay, so you can write like this. Yes. Okay, so don't give the my path. Okay, Kumar, Dipanshu, please give your path. Okay, so this is the my path. Okay, that's fine. Yeah, this structure of the path is right. Okay, the slash would be like this. Okay, so please give your path. Yes, everyone, please copy your path and give this. Just right here, right? Okay, fine. You know, okay. After that, we have to create one predictive function. Okay, so how can we create the predictive functions? Okay, so we are going to define one. We are going to define. Okay, here diabetic. Okay, simply I'm defining here the diabetic underscore prediction. Right, I'm taking the data as the input data. Input underscore data. Right, and you just copy the whole thing. Okay, you just copy the whole things from the Google Colab. Okay, So let me copy this whole the thing from the Google Colab. Okay. Just a minute. Let me check. Okay. Yes. Okay. So I just copy this code. Okay. So here I am going to define the one diabetic prediction. Okay. Defining the one function diabetic prediction and taking the input data. So similarly, the all the data, okay, all the data will be form of array because we are going to create one web kind of application. So inside the web application, there will be like no, it's there will be like different text. So inside the text, we will put enter the different value. So that time must we have to take the all the value in the form of array. Okay. So simply if you check the Google Colab part, okay, so we have also defined there the one diabetic prediction. So where we are writing the same code, we are taking the input data as a numpy, we are writing the input data as a receipt, and then we just writing the prediction. So in the prediction part, that time we are writing the writing the classifier part. Okay. But when you just when we are just created a train model, so that time you're writing the here but loaded model. So simply we are just copy this code from the pickles part. Okay. When you just we imported the pickle pass, and after that we in place of classifier we simply loaded the model. So that time we just copy these things and writing the here. Okay. And this predictive this diabetic prediction will just display if the person is getting the 0, that will be the diabetic person. If they are not getting the 0, that will be the non-diabetic person, right? Okay. So after that we have to define one main function. Okay. That will be the main function. So I'm defining here the def main. Okay. That will be the main function, right? So inside the main function, okay, why we are going to define the main function? Because inside this main function we will give the different titles. But what is the title? Title is basically like in the when you just title will be displayed in the your web part. Okay. So simply we will yes. Any query? Sir, I'm stuck. I'm using the MacBook. Please guide me. Yes, Streamlit no module is fine. Yeah. Dixika, if you're getting the Streamlit no module, the name is found. So please write pip install. Okay. Pip install Streamlit. Okay. If anyone find if you're getting the not error like pickle, so like just write the pip install pickle dash mixin. Okay. So you check the previous message. I have already written the two messages regarding the installation. One is the pip install. Again, I'm just copy this all the things and try to paste in the chat box. Okay. So please everyone just install the two things. One is the pip install Streamlit, another one is pip install yeah, pickle mix. Okay. Dipsita, you just copy these things, pip install Streamlit and pip install pickle mix. Okay. Fine. Yes, you write in the terminal. Okay. Please go to the Anaconda navigator, go to the environment and just you write in the terminal. Okay. Or you can just you can search on the your desktop or laptop like Anaconda CMD. Okay. Like Anaconda terminal. Okay. Or Anaconda prompt. Okay. You send search the Anaconda prompt. Inside the Anaconda prompt, you just write these things. Okay. Downloaded file of train model is not there. Okay. So if any file is downloaded in your system, so you can check your download section. The file will be present in the download section. Okay. So please you search on your file. Okay. Okay. So please yeah. So inside the main function we are going to define the title. Okay. So how can we define the title? So I'm simply writing here the set dot title. Okay. Simply writing the title. Okay. So inside the title, I'm putting here the diabetic prediction web app. Okay. So I'm simply writing here diabetic prediction web app. Okay. So simply I'm writing here the diabetic prediction web app. Okay. So that will be displayed in the web. Okay. Title. After that title, we are getting the input from the user. So how can we get the input from the user? So that time you have to define the text. Okay. So text will be available in the Streamlit library. So we have defined the Streamlit library. So we have to simply write here the pregnancy is the one column. Okay. So inside the pregnancy, we have simply, simply you just write here. Okay. ST. ST is the basically streamlit, and just write the text. Okay. Text is basically for the taking the input value. Okay. So you simply write the, this is the variable. So you simply write the text underscore input. Okay. Inside the input, we will take the values like number of the pregnancies. Okay. So simply writing here the number of pregnancies. Okay. Because this is the based on the data. Okay. What are the different value available on the data? So based on data, we are trying to collect all the data from the users. Okay. So you're simply writing here the pregnancy. Okay. Right. And you just write the you have to write the same code for each and every column. Okay. So just you write the for the glucose, blood pressure, insulin, BMI. Okay. You can just write for the all. Okay. When you just writing the please write the, please complete this task like you just write the pregnancy. For first you write for the pregnancy, after that you just write the glucose. Okay. Then when you just complete this task, after that we have to write here code. Okay. So we have to write here diagnosis. Okay. So we have to write here the diagnosis. Okay. So diagnosis, it will just reflect the particular person is diabetic or not. So simply we will write the diagnosis here. Okay. So inside this diagnosis, we will give the we will enter the blank spaces. Okay. So inside this blank spaces, we will put one. We will just create one button. Okay. That particular will button display the result. Okay. So simply we create here the button. Okay. So simply you just write st dot button. Okay. Simply you just write st dot button. Okay. Inside the button, you just write the diabetic result. Okay. What is the diabetic result? Diabetic test result. Right. Okay. We will write the diabetic result. Okay. And then we will just at the end we will write the this thing. Yes, so we will write the st dot success. Okay. So basically st is a streamlet. We are writing here the axis of success, and then we just display the diagnosis. Okay. Then we just display the diagnosis. Right. At the end, we will call the main function. At the end, we will call the, here we call the main function. Okay. Because we have all defining the all the text and all the things inside the main function. So at the end, we will decide, we will call the main function. Right. We will call the main function. Okay. So, okay, fine. Chandrasekhar success. Okay, fine. So please, can you confirm in the chat box, like till now, have you finished the task or this all task? Okay. So let me just stop the screen. I just want to share a few things. Okay. So, okay. Yes. Okay, fine. Yes. So you can see here, please finish this task. So inside we have just copy this same thing. I'm written the few things here. Okay. So I've just copy the same column again and again. So for the pregnancy, I've completed these things. Pregnancy dot st dot text input the number of pregnancy. Similarly, I copy the task like that is the glucose, level of glucose, and level of blood pressure, skin thickness, insulin, BMI, and diabetic pregnancy function and age. So you just simply you are creating the here the text. Okay. St dot text, you are creating the st dot images. Okay. Xt dot text. Okay. After that, there will be functions like to create the st dot button, that diabetic test result. Okay. We are creating these things. Okay. So please try to follow this step. Okay. After that, we will run this code. Okay. first you finish this code. After that, we are going to run this code. If you are going to run this code, okay, so you can see here, it's showing, it's a, it's displaying here. To view the Streamlit application in browser, you run the following code. Okay, so we have to run this following code. Okay, so we have to write this code in the, we have to write this code inside the terminal. Okay, we have to write the same code inside the terminal. Okay, so let me check. Is it working or not? It's able to create the web application or not? Let me check. Okay, no, we have to write, we have to put the all the things in the, let me run this. Okay. Are you able to see my screen? Okay, first you, just a minute. Okay. First you finish this task. Okay. Then we will run this. This part is completed. Okay. This web application is completed. Okay. When you just run this code, so you can see the console. Okay, so in this console we are it's showing here the showing the result. To view this Streamlit application on a browser, so we have to perform this task. Okay, so we have to just run this task only. Okay, so I'm just copy this simply and copy the code here. Okay, just a minute. So simply and copy this code here. See, I'm trying to share this terminal. So this is the Anaconda Navigator terminal. Okay, so I'm writing the code. Okay, so I'm writing the Streamlit run and I'm putting the location of this file. Okay, and now we are going to run this code. Okay, so see, so it says, just a minute. Okay, so are you able to see this thing? So it's the displaying the result. Okay, you can now view your Streamlit application on your browser. Okay, so where is the browser? Okay, so you can see here. So this is the browser. Again, I'm trying to open this file. Okay, so so this is the browser. Okay, so we have created this web application. Okay, right? So when you just run this code in the terminal, okay, so that time you will get this kind of output. Okay, so we have successfully created this web application. Okay, are you able to see my web application? Are you able to see my web application? Please confirm in the chat box. Are you able to see this web application? Okay. Now you just enter the value. Now I am going to enter the value, and we have to check this model is working or not. Okay. So I'm simply putting the value of from the database. So in the pregnancy, I'm putting the 6. Okay. Putting the value 6. In the glucose level, I'm putting the value as a 148. Okay. You can also check in the your data set. In the blood pressure, I'm putting the value as a 72. Okay. In the skin thickness, I am putting the value 35. In the insulin, I am putting the value 0. In the BMI, I am putting the value 33.6. Okay. In the diabetes, I am putting the value. So according to data set, we have to putting the value 0.2, 0.627. Okay, so you can check the data set. I'm just entering the first value. Okay, So in the first value, you can check pregnancy 6, glucose is 148, blood pressure 72, skin 35, insulin 0, BMI 36, and diabetes is 0.27, and the age is 50. Okay. So outcome must be 1. Okay. So outcome must be 1. Okay. So, okay. So let's run this code. Okay. And let's see what is the output here. Okay. So now we are able to see this, this web application is displaying the result. This person is diabetic. Okay. It means we have successfully created the machine learning model. Okay. And with help of this Streamlit library, we created the one success. We have created a successfully web application. Okay. And now we are our model is working very well. Okay. Now we are getting the very good output. Okay. So you can also enter the different values. Okay. And you can check how your model is working good or not. Okay. So can please tell me the code from the first and help the getting it, please? Yeah, yeah, sure. Okay. So please tell me like where you're stucking. Okay. So please tell me your step. First, let me share my spider notebook. Okay. I think most of the people are stuck in the spider. Okay. Because we have to install few library. Okay. So this is the spider, this is the spider code. Okay. So please check, you have to, it's a very simple code, we have already created a predictive part. So we have just copied this code from the Google Colab. So we have only simply created a one function. So inside the main function, with help of this Streamlit, we have only created this task. First we created here the diabetic prediction web application. Okay. So in this set title, we can put anything. You can also put your name, or you can put anything. You can put any string. Inside this title, you can put anything. Then after that, you have to just created a 6 text. Okay. We have not created any radio button or not created any complicated code. We just copy this code 6 times. Only change the value like frequency, glucose and blood pressure and everything. Okay. Rest of the thing is same. Set dot text underscore input, set dot text underscore input. So writing the same code again and again. Okay. Then after that, we are going to just put this set dot button. Okay. So it's basically display the result here. Okay. Set dot button. Right. And at the end, we are finally calling the main function. So because we are writing the whole code inside a main function, so we have to call the again function, so that if you're going to run this code set button, so that time you can able to get the that time you get the output from the your prediction model app. Okay. So I want to talk, sir, need to explain the error. You can write in the chat box. Shivani, you can write in the chat box. From the download file, I pasted the path, but it's so Unicode error. Okay, Unicode error. Fine. Yes, Shivani. You can check here in a if you're getting this kind of error. I got your error. Okay. So you can simply the error, the only error is related to is the backslash only. Okay. So I'm writing these things in chat box. You can just, we follow this step only. Okay. So you give the slashes like this. Okay. Suppose this is my link. Okay. So yeah, Dixita, are you able to see my, I just send to the everyone. Okay. So this is the link. Okay. So you have to put the slashes like this. Okay. So anyone just putting the forward or backslash. So please write this code, because if you are going to copy this link from the desktop, for that time the slash will be different. Okay. And this time you have to put like this. Okay. Because this Python can understand only this slash only. Okay. So you just put this slash and then your code, your error will be resolved. Okay. If anyone is getting the Unicode error, so please put the link like this. Okay. Sir, from where you added the diabetes prediction in the if block? Yes. So you are talking about this if block. Okay. So this if block is, you check the pickles part. Okay. In the Google Colab, you check the last 4-line code. So we have inserted the pickles. Okay. So inside the pickle, there is a model we have created the if else part. So you just copy this code from the Google Colab only. We have created one. We are first we taking the data in form of tuple, then we are going to put the in the form of array, then we receive the data, and then we try to predict the model. So basically, just copy this code from that Google Colab. Okay. Only in this string with help of Streamlit, we just define one function and take just mention the one title app. After that, we are just writing this code. We are writing this as set.text. Okay, set.text. We are writing this code only, and after that we just defining the if you're after that we are going to write the set.button. Okay, so from this Streamlit we are using this title, text, and button. These three things we are going to writing new things from because all the things are from the Streamlit library. So with help of this Streamlit library, we are just inserting this title, set.title, okay, inside the main function, and then we are going to use the set st, basically st the Streamlit, st.text, st.title, and the st.button. So these three things, this three method is only just coming from the Streamlit library, and the rest of the things are copied from the Google Colab. Okay. Can you explain the consoling part again? Which consoling part? Like I think you were talking about the this terminal part. Okay. So yeah, let me share my screen. I think you are talking about the terminal, right? Lahri, you are talking about how can we install the things in terminal. Yes, Sivani, this time you are writing the good code. Okay. Yes. Now you can run this. This time I will definitely will not get this Unicode kind of error. Okay. So this time you are writing good code. You can go ahead. Okay. Yes, Larry, you were talking about. So, uh, can you explain me about Larry? Well, like, what is your question? Yes, Vinay, you are asking diagnosis underscore diagnosis. Okay, yeah. So diagnosis part, right? So in this diagnosis part, we are including all the things. Okay. So we including all the data in the form of list. Okay. Because based on that, the data based on this is insulin, BMI, insulin, blood pressure. Based on this data, we are trying to collect. We are trying to analyze our result. Okay. Because there is an output column. So how can we decide your output column based on your all the features? So basically, we are considering all the features from your features from this. We try to store the feature in form of list. Basically, that capital bracket now, that large bracket is called the list. So install we just defined here the one function that is the diabetic underscore prediction. Inside this particular function, we are storing the whole data, and based on that data, we are going to diagnosis. Then we just here written here st dot success diagnosis. So basically, the diagnosis will collect all the information from this data, right? Then we can display all the value. Can we show the start code? I will take. So in the starting code, in the starting code, we are only including this library. Okay. So including the NumPy, pickles, and a Streamlit library. Okay. And then we are going to load this model. Okay. So we are loading the model with help of pickles dot load underscore model. Okay. Pickles dot load. Okay. So we are going to just open this model with help of this library. Okay. And then we copy this code from the creating the function of prediction. We'll copy this code from the Google Colab. Okay. Because we have already defined the function. So just copy this function to accept all the data in the form of array. And we are putting the condition here. If the error, if the prediction is getting, if the prediction is equal to 0, so that time the person is not diabetic. If getting the 1, so that time the person is diabetic. So 1 for the diabetic and 0 for the non-diabetic. Okay. Right. Okay, fine. Any other queries? So this is the web application. Okay. So you can now come to the web application. So we have created successfully. We have created this web application. Okay. So you can say this. See, this is the title. So in place of title, you can write anything. if in place of, this is the text messages, so I'm writing, just writing the written these things, number of pregnancies. So you can write anything. So you can also change the font. You can also add the colors. You can also, if you're going to explore the Stimulate library, you can make it very attractive web application. Okay. You can also put, we can also create here the image. Okay. And you can put the image of related to diabetes patient. Okay. You can, in place of diabetes result, you can also create some different kinds of buttons. Okay. You can make, you can explore the library of, about the Stimulate. You can make the very attractive page. Okay. So with help of this two file, so we will add one very small file regarding the proc file and text file. Then we can deploy in any cloud platform like AWS, like Azure. You can their estimate also there, like Heroku is there. So we can deploy now. This web application is running on our local server. So it's, if the particular application is running on the local server, so after that we can deploy in any cloud server. Okay. So now we have successfully developed the web application on this local server. So we, after that we can easily deploy all the things in the cloud. Okay, with help of Git. So first we have to just create a one Git profile. We have to add this all file and we can deploy it on the cloud. Okay. So the major task is the for creating the writing the code for the creating the model, and the writing the code in the with help of this Streamlit library or the Flask. You can also use the Flask. Okay, but Streamlit very easy. It's very basic. So you can explore Streamlit. Okay, so that will be the better. Yes. Any question? Can you use the data which is given in the list? Yes, yes, you can use. You can use. Okay, just tell me the data. I will just enter and you can check the result here. Yes, you can just put the data in the chat box. I'm going to enter here in the in this local service and you can check the result. Okay. Are you able to see my screen, or are you able to see my web application? Please confirm. Are you able to see this web application in chat box? And please enter your, please enter your all the any value from your database. Okay. Yes, so please enter your any value from the your database, your data set. I will enter here in this local server, and you can check the result. Okay, it will display the 100% accurate result. Okay, you can enter any value in chat box. Okay, accordingly I will enter the value. So you can write the number of, yeah. Sir, please show the spider code once again. I want to take a screenshot. Okay. Yes, sir, definitely. I will share the. I will show you the code. Okay, but can anyone just enter the different value in the chat box so that I can enter the value in the web application? Yes, right. So 3 is a pregnancy. Okay, right. I'm entering the 3. Glucose level is 200. Okay, just a minute. It's 200, and this time I'm entering the blood pressure 1110. Okay. Thin thickness is 35, insulin level is 25. That's nice. Okay, and the rest of the thing is 35 point, okay, 25, 35.5. Okay, and 20. Fine. No, is age of the person is 20. No, what is the age of person? Age of the 30. Okay, fine. So that's that's the night. Let me write the post 20, as age of the person is 30. Okay. Okay. So I'm running this code, running this application. So you can check the. So it's displaying the result is diabetic. So please, other confirm is the person is diabetic or not. Our web application is going to display the result as a diabetic. Ajay, can you confirm is it correct or not? Okay, fine. Thank you. Yeah. Yes, yes, yeah. Please, Devaprita, please tell me what is the error you are facing right now. Yes, please tell me, like, it's showing name is not defined. Okay, fine. Okay. So let me share my the Jupyter Spider notebook. Okay. Yes. So if you're getting, if you're facing the error like name is not defined, so you can just check this name. Okay, train underscore model dot sav. Okay, so you can check the any syntaxes, like you can also check the name on the form of lowercase and uppercase. So if you define, if you written the train as a capital T, so that time it will display the error like the name is not defined. So please check the name, check the syntax, like check the uppercase and lowercase of each and every letter. Okay, that will be the better. And check also spaces and the put the single quotes, okay, in the RB, and put the single quotes inside this path. Okay, after that your query will be resolved. Okay, after that your error will be resolved. Okay, so please write in this proper manner. Okay. Any other queries? Uh, any other queries, please write in the chat box. Okay, so how many like you have completed this task from starting to beginning, like from beginning to starting to ending part, like how many like got you the your web application? Can you write in the chat box? Is the web application is working on? Yes. So Pratibha, thank you. Dipsita, thank you. Yeah. Yes, Kishore, thank you. Darshana, thank you. Yeah. Okay. Okay, that's great. Okay, fine. Uh, Mehul, am I audible?
Yes, Saurabh.
Yeah, over to you, Mehul. Yeah.
Great. So thank you so much, Saurabh, for delivering the wonderful and insightful workshop today. And I hope people, love the session.